Now, let us try to solve some of the numerical problems in the unit solution. The first question is, which of the following is an SI fundamental quantity? We know the fundamental quantities in SI unit. There are 7 basic fundamental quantities. Okay, what are they? Length, time, then mass is there, then ampere is there, okay, then Kelvin, okay, then candela, mole, then 2 derived supplementary quantities also there. Not derived, supplementary quantities, that is radian for angles, for plane angle, and steradian, okay, steradian for solid angle. Okay, so these are the 7 fundamental quantities. Okay, these are 7 fundamental quantities. So let us see what are the things given. Given is actually velocity, force. Velocity is not a fundamental quantity. Force is not a fundamental quantity. Mass is of course a fundamental quantity, and energy is not a fundamental quantity. Therefore, the answer is mass 3. Okay, mass is the answer. Now, question 2. What is the SI unit of luminous intensity? So, luminous intensity is the basic unit, mean the fundamental unit, that is actually candela. Answer is candela. Candela. Okay. Next one. Which of the following is a derived unit? Mean which is not a fundamental quantity is a derived unit. For length, we know in SI unit, length is in meter. Then time is in seconds. Then mass is in kilogram. Then current is in ampere. Okay. Then thermodynamic temperature is in Kelvin. Then luminous intensity is in candela. Then mole is for amount of substance. Okay. Now here the correct answer is, which is the derived unit. Meter is a basic unit. Kilogram is a basic unit. Second is a basic unit. Then the answer is Newton, which is derived unit. What is Newton? Newton is the unit for, Newton is what? For what? Newton is for force. Okay. What is force? Force is equal to mass into acceleration. Okay. Mass into acceleration. And mass into acceleration means actually only one fundamental quantity is there, that is mass. Acceleration is again, what is that? Distance by time square. Okay. That means ml t raised to minus 2. This is the dimension. So this is a derived quantity. Okay. Now the fourth question. Let's go to the fourth question. Fourth question. What is the dimensional formula for force? Just now we derived. Okay, what is force? Force is equal to mass into acceleration. So ml t raised to minus 2. Okay, so it is ml t raised to minus 2. Answer is given here. This is answer 1. Next one. Which of the following is not a correct pair of physical quantity and SI? And it's SI unit. So there are physical quantities and there are SI units are there. So just now we have mentioned here, length is for meter, time is for second, temperature is for what? Temperature is for Kelvin, not for Celsius. What is given is actually Celsius, that is wrong. And the electric current is ampere, that's correct. So temperature is for Kelvin. Celsius is not an SI unit. Okay. So the wrong answer is which is not a part. A pair is such a temperature. Celsius is not a pair. So that's wrong. So the correct answer is 3. Okay. Now next one. Q6. Question 6 is, if the dimensions of physical quantity are given by ml square t raised to minus 2, then the quantity is. Now it is given ml square t raised to minus 2. So what this can be? This is actually ml square t raised to minus 2. The answer given here is wrong. It is not 3. It is actually 2. Okay, ml square t raised to minus 2 means actually it is energy. So mass into L square means actually meter square, kilogram, meter square. Okay, second raised to minus 2. It's kilogram meter, second raised to minus 2 is joule actually. It is joule. It is the it is for energy. So energy is equal to force into distance. Okay. So force, just now we have derived ml t raised to minus 2 into L means ml square t raised to minus 2. This is nothing but energy or work. Work and energy is the same. Okay. So it is energy. So answer given here is not correct. This is not 3. This is actually 2. Okay. Okay. Next one, Q7. Q7. A new unit of length is chosen. A new unit of length is chosen such that the speed of light is vacuum in unity. What is the distance traveled by light in 2 seconds in this new unit? So here, what is given? Speed of light. We know what is the speed of light. Speed of light is 3 into 10 raised to 8 meter per seconds. Okay. So here actually new unit. New unit, what is given? The speed of light is given as 1 unit. 1 unit in vacuum. So 1 unit speed of light means actually 1 unit per second. Okay. That is speed of light. So here in 2 seconds it will travel 2 units in, because actually the speed is actually so much distance per seconds. So speed of speed is given instead of 3 into 10 raised to 8 is given 1 unit, 1 per second. So in 2 seconds it is 2 units per second. So the answer is 2 units per second B. Next is question 8. It is light year is a unit of. What is light year? Light year is the distance traveled by light in 1 year. Okay. So we know 3 into 10 raised to 8 meter per second. That is per second, right? If it is actually per minute, multiply by 60. If it is per hour, okay, you get multiplied by 24. Then if it is per day, you have to multiply 365.25. So this is the speed of light. Okay. So actually this is a distance. Actually, distance traveled. The distance. It is a distance traveled. So it is a unit of distance. So light year is a unit of distance. Okay. So the answer is C. Next, physical quantities are, what are physical quantities? Okay, that is the question. So question 9, Q9. Physical quantities are quantities such as kilos, pounds and gallons. Quantities such as pound, dollar and rupees. Okay, quantities such as length, mass, time, electric current, thermodynamic temperature, amount of substance, luminescence. It is SI fundamental units. Okay, so physical quantities are quantities like this. Okay, and it can be actually the question shall be the basic physical quantities. Okay, these are the, in SI unit, this is the basic physical quantities: length, mass, time, electric current, thermodynamic temperature, amount of substance and luminescence. Now the quantities which can be described by the law of physics known as physical quantity. Physical quantity is one that can be measured. Length, mass, time, pressure, temperature, current and resistance are the physical quantities, and it can be a physical quantity mean even actually derived quantities are also physical quantities. Okay. Now next question, which of the following has the same dimension? Surface tension and force, then moment of inertia and torque, impulse and momentum, specific heat and latent heat. So let's see which one is having the same dimensions. So let's first consider surface tension. Now the surface tension is a force per length. Okay. Now surface tension is equal to force per length. It's equal to force, we know, mass into acceleration by length. That means actually m, acceleration is distance by time square, L by t square means L t raised to minus 2. Okay, divided by length means m t raised to minus 2. Surface tension is m t raised to minus 2. And force, we know, just now we have calculated ml t raised to minus 2. Force is ml t raised to minus 2. So these are not same. First case is we have omitted the first case. Okay. Now more pages, we will add more pages here. Okay. Next is actually moment of inertia and torque. What is moment of inertia is equal to m r square. Okay, there is the formula for that. M into r square is L square. Moment of inertia is m r square. And torque, we know what is torque. Torque is actually if in an object two forces are in opposite direction, then there is a tendency to rotate. Okay, so there is actually the distance. Distance is there. There is one force is there. So it is nothing but force into distance. That is nothing but work. It's energy. So torque is equal to force into distance. Okay, we are saying one force and distance. So it is nothing but force is mass into acceleration, we know, into distance. So we can say m into Lt raised to minus 2. Why? Because acceleration is distance by time square. Okay, Lt raised to minus 2 into L. So it is m L square T raised to minus 2, nothing but energy or work. Okay. So torque has dimension same as work. So moment of inertia is as you have dimension m square, and torque is having m square T raised to minus 2. So it is not the same. Impulse and momentum. Impulse, we know that is actually force into time. Okay, a small time, delta t. That is impulse. So force, we know, mass into acceleration is mlt raised to minus 2 into t. That is m L square T raised to minus 2. Okay. Sorry, m L square T raised to minus 1. T raised to 1 and T raised to minus 2. M L square T raised to minus 1. Okay. Similarly, if you go for momentum, mass into velocity, momentum is mass into velocity, that is m into velocity is by time, this is by time, that is, okay, m L T raised to minus 1. Okay. This both are same. M L T raised to minus 2 and T raised to minus 1 is m L T raised to minus 1. So impulse and momentum is having the same dimensions. Okay, that's correct. Next is specific heat and latent heat. Okay, so specific heat and latent heat, what is specific heat? Specific heat is actually it is the amount of heat energy required to rise the temperature delta T of a unit mass of a substance by 1 degree. So the formula is actually Q. Q is the energy divided by mass and temperature. Okay, so M delta T. So you can see that actually Q is a Q is energy, heat energy. Therefore, it is an energy. So ml square T raised to minus 2 divided by mk. Okay. So the dimension for specific heat capacity is L square T raised to minus 2 T raised to minus 1. Okay. Now similarly, there is actually the formula for latent heat is L is equal to Q by M. Okay. L is equal to Q by M. Q is energy. It is actually energy is, we know, m L square T raised to minus 2. Why? Force and distance is energy. Okay. Force is ml T raised to minus 2 into L. Again, that is ml square T raised to minus 2. So Q by M. So it is actually L square m L square T raised to minus 2. M square L square T raised to minus 2. So these are not the same. Okay. So that is not the case. Therefore, that the correct answer is momentum and impulse. Next question is, which of the following is same as the dimension of kinetic energy? So it is very clear. Kinetic energy is an energy. Okay, energy, and the given answers is work. Work and energy are the same. So work and energy is the same. It is actually, the answer is option A, work. Okay. Next is electron volt is the unit of energy. Okay, electron volt is the unit of energy which is commonly used in atomic and nuclear physics, equal to the energy gained by the electron. When the electrical potential at the electron increases by 1 volt, V is equal to W by Q. Okay, so W is equal to Q. So electron volt is for energy. Electron volt is for energy. Okay. Now next one. So electron volt, when we say electron is actually, E is actually for charge, V is for volt. So it is Q into V. Okay, so V is equal to W, V is equal to W by Q. So it is nothing but Q into V. Okay. Next one. What is the unit of solid angle? Solid angle means it is solid angle. Solid angle is steradian. Steradian is actually area by r square. Okay, steradian, we have learned actually steradian is area by r square. Area, it is L square, r square is again L square. That means it is dimensionless, no dimensions. Okay, no dimensions. For steradian, there is no dimension. The unit of solid angle is steradian and is having no dimensions. Now, next one. If the percentage error in length measured is 2% and breadth is 3%, the maximum percentage error in area measurement. So we know area is equal to L into B. Okay, length into breadth. So when it is two physical quantities and the errors are actually length measurement is 2% and breadth measurement 3%, we have to add both. Okay, so it's 2% plus 3%, that will give 5%. Okay. Next one. The assertion is significant figures are used to express the precision of measurements. Reason is they indicate the number of digits that are known reliably. Okay. So let us see whether the assertion and the reason are correct or whether true or not. So the assertion is significant figures are used to express the precision measurements. They indicate the number of digits that are known reliably. Both assertion and reason are true, and reason is the correct explanation of the assertion. Now let us see the dimensional formula for the coefficient of thermal conductivity. So we know Q is equal to minus K into A into dt by dx. And what is Q? Q is the heat transfer rate, mean energy per energy transfer rate. The heat is nothing but energy, heat energy. So energy per rate. So energy per time. So it is energy divided by time. So nothing but energy is actually ml square t raised to minus 2. We know time is t. So Q is equal to m L square t raised to minus 3. Okay. Now A is the area is equal to L square, and dt by dx is the temperature gradient. Temperature we know is Kelvin, then dx is length, mean actually temperature per length. Okay, so the thermal it is the temperature gradient. This is K L raised to minus 1. Okay, so then from the expression Q is equal to minus K A dt by dx, which implies K is equal to Q divided by A into dt by dx. So it is nothing but m L square t raised to minus 3 divided by A is L square into dt by dx is equal to K L raised to minus 1. So it will be that m raised to 1. Okay, now here 1 L square cancels. Now it is 1 L raised to minus 1. When it goes up, it is L raised to 1. Then t raised to minus 3. Okay, t raised to minus 3. Then K1 goes up, it will be K raised to minus 1. So it will be m raised to 1, L raised to 1, t raised to minus 3, K raised to minus 1. Okay. Let us see what is the answer. So it is the first answer, m L1 t raised to minus 3, K raised to minus 1. Next one. If LQR represents inductance, charge, and resistance respectively, the units of 4 options are given. Okay, so you have to find the unit of QR by L. So Q is charge. Okay. Then R we know Q is equal to IT. We know that is actually A into T. We giving dimensions are A into T. So okay, now one more thing is there. Okay, we will solve by two methods. Then actually R is equal to resistance is equal to V by I. We know is the V by I. V is nothing but W by Q into I. Okay, W by Q is V, voltage potential. Okay, work by charge. So it will work, we know, ml square t raised to minus 2. Charge is A into T. Okay, into I. I is again A. So it is ml square t raised to minus 3, A raised to minus 2. Okay, that is resistance. This is resistance. Okay. Also, we know XL, the inductive resistance, is equal to omega L. Okay, which implies L is equal to XL by omega. XL is nothing but resistance. So it is ml square t raised to minus 3, A raised to minus 2 divided by then omega. Omega is actually t raised to minus 1. Okay. So it will be m L square t raised to minus 2. Okay. T raised to minus 2. Then A raised to minus 2. But what we want to find out? We want to find out is actually LQR, the represent inductance, charge, and resistance respectively. The units of Q into R by L will be those of current. Okay. So now R by L is equal to R, we have calculated here. So R is actually m L square t raised to minus 3, A raised to minus 2 divided by L is equal to m L square t raised to minus 2, A raised to minus 2. Okay, minus 2. So this get cancelled, this get cancelled. Okay, now t raised to minus 3, which is minus 2 is t raised to minus 1. Now Q into R by L is equal to Q is A T into t raised to minus 1 is equal to nothing but A, ampere. Okay, so it is the QR by L, the first one will be those of current. Okay. Next one, the quantity half epsilon square E square has dimensional formula, same as which one? We have to see which one we have to say whether the half CB square or half LI square or half B square by V0 or power. So we know that F is equal to 1 by 4 pi epsilon 0 R square into Q1 by Q2. We know that F is equal to 1 by 4 pi epsilon 0 R square into Q1 Q2. Okay. So from this, epsilon 0 is equal to 1 by 4 pi FR square into Q1 Q2, which is nothing but 1 by 4 pi MLT raised to minus 2 L square into AT square. Okay, this is false. Okay, so it is okay, that is for epsilon 0. So epsilon 0 is equal to m raised to minus 1, then L into L square L cube. When it goes up, it is L raised to minus 3. It is t raised to minus 2 goes up t square. Already t square is there, therefore t raised to 4. Then A is there, then okay, then 1A is A square is there, this A square, this is epsilon 0. Okay, epsilon 0 m raised to minus 1, L cube L raised to minus 3, t raised to 4, then A square is already there, A square. This is epsilon 0. So E is equal to electric field. Okay, electric field. Electric field is force by charge. It's equal to F by Q. Okay, is equal to ml t raised to minus 2 by at is equal to m l t raised to minus 3 a raised to minus 1. Then when we calculate epsilon 0 E square is equal to epsilon 0, we have already formed it here. It is m raised to minus 1 l raised to minus 3 t raised to 4 a square, okay, into, we know that is E. So when square is taken, m square l square t raised to minus 6 a raised to minus 1. Okay, so what we will get? We will get m raised to minus 1, then m square we will get 1 now, only m raised to 1, l raised to minus 3 and l square we get l raised to minus 1, then t4 t raised to minus 6 we get t raised to minus 2. Okay, so the product of epsilon 0 E square, okay, epsilon 0 E square, epsilon 0 E square is equal to m l raised to minus 1 t raised to minus 2. Okay, now let us see which one will give the same result. So there we have half b square by epsilon 0, the third one C, half b square mu 0. Okay, then we know B is the magnetic field. Okay, mu0 is the permeability of free space. So we know F is equal to QV into V, which implies B is equal to F by QV is equal to ml t raised to minus 2 divided by at into velocity lt raised to minus 1, which will give what we will get there. B we will get okay, we will get B as actually m is there m raised to 1, then t raised to minus 1 t will get cancelled, then m l and l will cancel, m raised to minus 1 t raised to minus 2 a raised to minus 1. Okay, so we got B here. Now we will find the b square by mu 0 we will find. Now we have to find mu 0. So we know b is equal to mu 0 I divided by 2 pi r. Okay, which implies mu 0 is equal to b into 2 pi r divided by I. It will be already we got it m raised to 1 t raised to minus 2. Okay, t raised to a raised to minus 1 into r is L. 2 pi is a constant, therefore there is no diameter for this. L divided by I is A. So what we will get m1 t raised to minus 2. Okay, then L is there. So ml l raised to 1, m raised to 1, then here 2 pi into r divided by I. So mu 0 m1 l1 t raised to minus 2 a raised to minus 1. Okay, a raised to minus 2. Okay, ml t raised to minus 2 a raised to minus 2. Now half b square by mu 0 is equal to b square b. We know we have find out m1 t raised to minus 2 a raised to minus 1. Okay, the whole square divided by mu 0, already mu 0 is here. Okay, this is B. So mu 0 is ml t raised to minus 2 a raised to minus 2, which will give m square t raised to minus 4 a raised to minus 1 divided by ml t raised to minus 2 a raised to minus 2. So what we will get, m square and m, we have m here, m raised to 1, then l raised to minus 1. Okay, when it goes up, the t raised to 4 t raised to minus 2, okay, we will get t raised to minus 2. Then we have a raised to minus 1 and a raised to a raised to minus 1, the whole square is actually a raised to minus 2. These two get cancelled. So m1 l raised to minus 1 t raised to minus 2. So we are getting half b square by b 0 m1 l raised to minus 1 t raised to minus 2. Okay, the same thing we have got here also, b 0 e square m1 l raised to minus 1 t raised to minus 2. So the answer is 3, half mu 0 by b square by mu 0. It will have the same dimensions as mu 0 e square. Okay. The next question is, a light year is a unit of. Light year, we know that the unit of distance. Already we discussed this thing. Okay. Now, answer is actually light year is a unit of, not 1. This answer is 3. Distance. Okay. Next one, which of the following is not equal to watt? Okay. Now joules per second. Joules per second is power. So it is energy per second is nothing but power equal to watts. Ampere into volt, V into I. Okay. Ampere into power, V into I. V into I is again it is power. Then ampere square into ohm means resistance. So I squared R. I squared R is equal to I squared into R is V by I again. So it is V into I, it is again power. This is also power. Then again essentially joules per second, we know it is power. Then V is equal to then I into R. Okay. So joules per second we covered, then ampere into volt. Ampere into volt. VI. Here I by V. Second one. Sorry, the last one, fourth one. Ampere by volt is I by V. I by V, here actually V is equal to IR. So again I by IR. So it is 1 by R, it is conductance. It is the reciprocal of resistance is conductance. So ampere per volt is not equal to watt. Newton second is the unit of. So Newton second is force into time. Okay. So force into time is nothing but momentum. Force into time is nothing but momentum, is the unit of momentum. Which of the following is not represented in correct unit? Now we say stress by strain. Strain has no unit. Stress is actually, it's equal to pressure. Okay, force by area. So Newton per meter square is actually force by area. It is correct. First one is correct. Okay. Now surface tension is force by length is actually, force is Newton, length is meter, then force by length. Pressure is Newton per meter square. Then energy is equal to force into distance is actually kilogram meter into, mean force is actually MA. M is kilogram. Okay. Then A is equal to meter per second square or meter per second raised to minus 2 or into M. You will give actually kilogram meter square second raised to minus 2 is joule. So this is kilogram meter per second is wrong. It should be joule. 1 second is equal to, now 1 second is defined as the duration of 9,192,631,770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium-133 atom. So the correct answer is 4. 9,192,631,770 time periods of cesium rock. Okay, now 1 nanometers we know it is 10 raised to minus 9, nothing much to say there. Micron we know 10 raised to minus 6, there is also nothing more to say. Okay. So students A, B, C measure the length of a room using 25-meter long measuring tape of least count 0.5 centimeter and a meter scale of least count 0.1 centimeter and a foot scale of least count 0.05 centimeter respectively. If the specified length of the room is 9.5 meter, which of the following students will report the lowest relative error in the measuring length? So, as we know, the lowest relative error will have the instrument which is having the smallest least count. Therefore, we will get actually least count. The student C, who is using a meter scale of least count 0.05 centimeter, will have the lowest relative error in measured length. Okay. The answer is 3. An instrument with a small least count will have definitely high precision. So as the least count becomes small, the precision increases. Let us see what is precision, accuracy and least count. Precision is the repeatability of measurements. So it refers to the repeatability of measurement. If you measure something multiple times with the precise instrument, means that the measurements will be very close to each other. It means when you do some measurements, how close the measurements are to each other that is called precision. On the other hand, accuracy refers to how close the measurement is to true or accepted value. An accurate measurement provides measurements that are close to the actual value. That it is not required that it is actually closer to the measured values. So how close the measured values are, which refers the precision, whereas accuracy refers how close it is to the true value. Least count is the least count of measuring instrument is the smallest value that it can measure. For example, a ruler might have at least 1 mm, while the vernier caliper could have a least count of, okay, a ruler might have a least count of 1 mm, while a vernier caliper will have a least count of 0.1 mm. So the smaller least count mean the instrument can measure smaller increments, suggesting higher precision. If the error of a measured if an error in the measurement of momentum of particles is 100% plus 100%, then the error in the measurement of kinetic energy is. So how we will find this? So kinetic energy, we know it is referred by p square by 2, where m is the mass and p is the momentum. Okay. So when the error is actually 100%, means the new momentum will be p plus p is equal to 2p. So with this, if you calculate the kinetic energy, p square by 2m is equal to, instead of p, we have to use 2p. So it is 2p square divided by 2m is equal to 4p square by 2m. The difference if you are taking, you will get actually 4p square by minus 2m minus p square minus 2m. So you will get actually 300%. So the percentage error is actually delta ke by ke is equal to into 100, means 3 into p square by 2m, okay, divided by p square by 2m in 100 is 300%. The error in measurement of kinetic energy is 300% here. Now, which of the following quantities have the same dimensions? First one is magnetic flux square by electric resistance, then torque into time, moment in length, power by time. So let us see. We know F is equal to BQB, which implies magnetic field B is equal to F by QB. So F we know ml t raised to minus 2 divided by Q is AT and velocity is L t raised to minus 1. We will get m t raised to minus 2 a raised to minus 1. So magnetic flux is defined as the product of the magnetic field and the area through which it passes. So magnetic flux phi is equal to BA cos theta. Okay. So magnetic flux cos theta, there is no dimension. Therefore, B into A mean BB already calculated m t raised to minus 2 a raised to minus 1 into L square. So we will get m L square t raised to minus 2 a raised to minus 1. So first answer given is magnetic flux square by electric resistance. So magnetic flux we have calculated. Now we have to calculate resistance. Resistance is equal to V by I. So that means that work by charge into I means ml square t raised to minus 2 by at into the ml square t raised to minus 3 a raised to minus 2. So phi square by r is actually ml square t raised to minus 2 a raised to minus 1 the whole square divided by r is ml square t raised to minus 3 a raised to minus 2, which will give m L square t raised to minus 1. Again, torque into time. Next one is torque into time. Torque into time is, torque is actually same as energy, ml square t raised to minus 2, and into time means ml square t raised to minus 1. Momentum into length. Momentum is actually m into v is ml t raised to minus 1L. Okay. Momentum is m into v means ml t raised to minus 1 into L. That is ml square t raised to minus 1. Power by time is equal to energy by time and the energy by time square. So there is energy by time ml square t raised to minus 2 by time square. Actually this time square. There's a mistake here. Time square. So ml t raised to minus 4. So the same dimension we is having actually same dimension magnetic flux by electrical resistance, then torque unity, momentum length. A, B, and C will have the same dimensions. Okay, answer is 2. Now, which of the quantities below have the same dimensions? Electric field into magnetic field by mu 0, epsilon 0 into electric potential square velocity by area, power by area. Here, the electric field means E is equal to F by Q. So F is equal to ml t raised to minus 2 by A T means ml t raised to minus 3 a raised to minus 1. Now, first one is we have to find actually electric field. Then we have to find B, magnetic field. Okay. So magnetic field is equal to F by QB. It's equal to ml t raised to minus 2 by at into lt raised to minus 1 is equal to mt raised to minus 2 a raised to minus 1. So mu 0, there are many methods of finding. So f by I square, f is equal to mu 0 I square force per unit current square. So ml t raised to minus 2 by a square ml t raised to minus 2 a raised to minus 2. So E into B divided by mu 0 is equal to ml t raised to minus 3 a raised to minus 1. Okay. So E is equal to ml t raised to minus 3 a raised to minus 1 into B. B is given as mt raised to minus 2 a raised to minus 1 divided by mu 0 is given ml t raised to minus 2 a raised to minus 2, which will give mt raised to minus 3. Epsilon 0, we know that actually 1 by 4 pi fr square into q1 q2. So 1 by f we know ml t raised to minus 2, r square is l square into q1 q2 a square t, a t raised to whole square a square t square. So we will get m raised to minus 1 l raised to minus 3 t raised to 4 a square. So V is equal to W by Q. So W is power, work. It is ml square t raised to minus 2 by Q is charge A into T or IT. Okay. So ml square t raised to minus 3 a raised to minus 1. So then we will see the second one, epsilon 0 electric potential square into velocity by area. So here epsilon 0 electric potential square, electric potential already we found ml square t raised to minus 3 a raised to minus 1. Then velocity we know L t raised to minus 1 will be area L square, epsilon 0 already we found. Okay. So when we multiply this, we will get m1 t raised to minus 3. So this is equal to E into B epsilon 0. So this both the things are having same dimension. In power by area, power by area is energy divided by time divided by area. Yeah? Power is energy by time. So ml square t raised to minus 2 divided by time. Okay. Time when it goes up it is raised to minus 1. L will, when it goes up it is raised to minus 3. This is mt raised to minus 3. So A, B and C having the same dimensions. All are having the same dimensions. Okay. So next one, which of the following sets cannot enter into the list of fundamental quantities in any system of units? First one is length, mass and velocity. So length and mass, velocity can have fundamental quantities because there is nothing common in this. Okay, length, time, velocities cannot have the fundamental quantity because velocity is nothing but length by time. So length and time, velocity means actually this is not the base quantities. This velocity cannot be the base quantity. When length and time are the base quantities, velocity cannot be the base quantity. That is the answer. A physical quantity is measured and the result is expressed as n into u, where u is the unit used and n is the numerical value. If the result is expressed in various units, then now let us see 1 kg. 1 kg can be expressed as 1000 grams. Here what happens? The numerical value increases. And then what happens? The unit reduces. Okay, it's a smaller unit. Here what happened? The numerical value reduces means the unit is a bigger value. Okay, kilogram. It's a bigger value. That means the numerical value is inversely proportional to the unit. Okay, the same is the case with the meter and centimeter. Okay, 1 meter is equal to 100 centimeter. Here also the numerical value increases, the unit reduces. So n is inversely proportional to unit. So what is the answer? Answer is actually 4. 4 is the answer. This is actually wrongly given. Answer is 4. Okay. Now next question. Suppose a quantity x can be dimensionally represented in terms of m, l and t. That is, dimension of x is equal to m raised to a, l raised to b, t raised to c. Then the quantity of mass can always be dimensionally represented in terms of L, T and X, can never be dimensionally represented in terms of L, T and X, may be represented in terms of L, T and X. If A is equal to 0, may be represented in terms of L, T and X if A is not equal to 0. Let us see how this problem can be solved. Now, as we know, here now we know x, the quantity x, dimension of x is equal to m raised to a, l raised to b, t raised to c. Let us suppose. Okay. Now, if that is the case, then m raised to a can be represented as x, divided by, okay, l raised to b, t raised to c. Okay. That means x raised to 1, okay, l raised to minus b, c raised to minus c. Now, when we separate m, that will be 8th root. Okay, just like square root, we are making 8th root. Is x raised to 1, l raised to minus b, c raised to minus c. Okay, what does that mean? When we remove that root, what will happen? X raised to 1 by a. Okay, l raised to minus b by a. Okay, just like actually if it was square root, we have to multiply with 1 by 2. Just since it is a, we have to multiply with 1 by a. Okay, into it is actually not c, it is t. Sorry, t raised to c. It is t raised to minus c by a. That means the a is coming in the denominator. Okay, so if a cannot be 0, if a is 0, it will go to infinity. So the mass M can be represented in terms of x, L and T provided A is not equal to 0. Okay, so let us see the result here. Okay, so see, just like this, M raised to A is equal to x by L raised to B T raised to C means x into L raised to minus B T raised to C. That means what is this? M is equal to x raised to 1 by A, L raised to minus B by A, T raised to C by A. This representation is valid as long as A is not equal to 0. If A were 0, then the term M would disappear from the equation and the mass could not be represented in terms of x, L and T. Therefore, if A is not equal to 0, then the mass can be represented in terms of x, L and T. So let us see the answers. What is written here can always be demonstrated represented in terms of L, T and x. Okay. So M can always be always is wrong, because if A is not equal to 0, then only it is correct. Okay, otherwise it is wrong. Can never be represented. That is also wrong. May be represented. That is also wrong. There is no maybe or anything. So may be represented in terms of L and T. If the condition is wrong, may be represented A is equal to 0. That is wrong. A is not equal to 0 is correct. Okay. Next question. A dimensionless quantity never has a unit. Okay. Now, dimensionless quantity can have unit also. Always have a unit, may have a unit, does not have a unit. There is possibility. For example, let us see angle. Okay. Angle is equal to, what is the angle? Arc length divided by radius. So it is L by L, it is dimensionless. So, but it is a unit, it is radian. Okay. Just like actually solid angle is steradian. Okay, we know it is steradian. So even though it is dimensionless, it may have unit. Okay. So next one, plane angle. Here example given, plane angle and solid angle. A unitless quantity never has a non-zero dimension, always has a non-zero dimension, may have a non-zero dimension, does not exist. Which is correct? Here, what we should understand is actually dimensions are normally expressed in terms of base units. So we know that in SAE system there are 7 base units out there. Okay. So normally length, mass and time, or maybe other base units can also be used if it is applicable. But when it is unitless quantity, it does not have any units at all, and therefore it cannot be expressed in terms of any combination of base units. Okay, that means it cannot have any dimensions. So a unitless quantity cannot have a dimension. So it isn't. It never has a dimension at all. Non-zero dimension. The dimension will be 0. That means there will not be any dimension at all. Okay, it is a dimensionless quantity. So answer is 1. Okay. The integral of dx by root of 2ax minus x square is equal to r is to n sin inverse x by a minus 1. Okay. Here we can see, since sin inverse x by a minus 1, we can say x by a is equal to 1, which implies x is equal to a. Okay. Now, a raised to n is equal to integral of dx by square root of 2ax minus s square. Since a is equal to x, 2ax is x square itself. Okay, therefore dimension we can write is equal to square root of dx by L square. Square root of L square. Okay, it is equal to L by L. Okay, L by L, that is 1. Okay, so integral of 1 means for getting 1, actually the dimension of L should be 0. Okay, that is L raised to 0. So now the left hand side, LHS, we got L raised to 0. Okay, it is L raised to 0. It's equal to A raised to n sine inverse, A raised to n sine inverse x by A minus 1. Okay, A raised to n sine inverse x by A minus 1. Forget this is actually the sine inverse x by A minus 1 is actually dimensionless. So we are getting actually L raised to 0 is equal to A raised to n. For this actually, for getting L raised to 0 is 1 here. To get 1 actually the dimension of n should be, the power of n should be 0. A0 should be, that should be 0. Okay, the power of A should be 0. That means n should be equal to 0. Okay. Okay. Next one. The dimension of ml1 t raised to minus 2 may correspond to. Okay. So, what are the things given here? Here, what is given is work done. First one is work done. Work done is equal to, we know force into distance is equal to ml t raised to minus 2 because it's equal to f into m into a. Mass is equal to m. A is equal to acceleration distance by time square L t raised to minus 2 into S. That means m L square t raised to minus 2. Okay, it is not matching with the m L raised to minus 2 t raised to minus 2. So next one is actually momentum. Linear momentum is mass into velocity is equal to m L t raised to minus 1. Okay, velocity is distance by time. So that is also not matching. Next one is the pressure. Pressure is equal to force by area. That is actually m L t raised to minus 2 divided by A square. Okay, that is m L raised to minus 1 t raised to minus 2. Okay, that is matching with the question. M L raised to minus 1 t raised to minus 2. You can see certainly m L raised to minus 1 t raised to minus 2. The matching with pressure. Okay. So next one is energy per unit volume. Energy is actually same as work. So m L square t raised to minus 2 divided by unit volume is L cube. That is m L raised to minus 1. Okay, m L raised to minus 1 t raised to minus 2. So this is also matching with the mg per unit volume. The answer is actually C and D. So the third one, the answer 3 matches with the answer is 3. So matches with the m L raised to minus 1 t raised to minus 2. Next question is choose the correct statement. Choose the correct statement. A dimensionally correct equation may be correct. Okay. So already we have discussed this. A dimensionally correct equation may be correct. So when an equation is dimensionally correct, it will be correct. It may be correct and it may not be correct. Why? Because dimensionally correct does not give guarantee to any of the other constants and all. Constants, the correctness of the constant, it is not guaranteed. Therefore, it is dimensionally correct. So, since it is dimensionally correct, it may be correct. Then, a dimensionally correct equation may be incorrect. That's also correct. Okay, that may be incorrect also. Because if the constants are not correct, it may be incorrect. Dimensionally incorrect equation may be correct. That is wrong. Dimensionally incorrect equation cannot be correct. Because if it is dimensionally incorrect, that means the equation is not correct. Dimensionally incorrect equation may be correct. So, that is dimensionally incorrect equation may be correct, may be incorrect. That's true. A dimensionally incorrect equation means that is incorrect. Okay. So A, B, and D are correct. Are the concerned statements. Okay. So 2 answer is 2. Next question. Consider the following statements. All quantities may be represented dimensionally in terms of base quantities. Okay. All quantities may be represented dimensionally in terms of base quantities. A base quantity cannot be represented dimensionally in terms of the rest of the base quantities. Yeah, a base quantity cannot be represented dimensionally in terms of the rest of the base quantities. The dimension of base quantity, other base quantity is always 0. The dimension of a derived quantity is never 0 in any base quantities. Okay. So when you say all quantities may be represented dimensionally in terms of the base quantity, that means that's why it is called the base quantities, because all other quantities can be derived, okay, using these base quantities. So that equation is correct. I mean, that statement is correct. Second one, a base quantity can be represented dimensionally in terms of the other rest of the base quantities, but base quantities cannot be derived. So these are the base quantity based on which actually other quantities are derived. Therefore, that's also the statement is also correct. Base quantity cannot be represented dimensionally in terms of the rest of the base quantities. Okay. The dimension of the base quantity in other base quantities always, since it cannot be represented in in rest of the other base quantities, then its dimension is always 0. So A, B, and C are correct. Okay. So next one is actually the dimension of a derived quantity is never 0. That is not correct. I mean, actually in SI unit there are 7 fundamental quantities are there. Then I mean, if you are consider, for example, force only M, L, and T are the base quantities we used, and other base quantities are 0 only. Okay, 7 base quantities are there. Out of this 3 only we are using. Other 4 base quantities are there 0. So the dimension of a derived quantity is never 0 in any base quantity. That is actually not correct, because some of the quantities may be having dimensions and other quantities may have 0 dimension. Therefore, the dimension of a derived quantity is never 0 in any base quantity is wrong. So the first statement is correct. Actually, choose the correct option. The first one is correct. A, B, and C are correct. Okay. Next one. The radius of a circle is 2.12 centimeter. Its area should be written as. Okay. When radius is given as 2.12 centimeter, 2.12 centimeter, and if it is 2.12 centimeter and circle, it is actually pi r square. That means 3.14 into 2.12 into 2.12. So it will come actually 3.14 into 2.12 into 2.12. Okay. So it will be 14.112416. But since it's having only 2 decimal points, we have to consider only 2 decimal points only. Therefore, we have to consider only these two. Therefore, the answer should be 14.11. Okay. Rounded to 2 decimals. The dimension of kinetic energy are the same as that of. So we know that kinetic energy is equal to nothing but an energy. Energy is actually m L square T raised to minus 2. Okay. Well, we can see work energy is actually force into distance. Okay. Force is equal to m into A into distance. That means actually m L so this is the time square is acceleration L T raised to minus 2. Okay. L T raised to minus 2 into L. Okay. So it is actually m L square T raised to minus 2. So kinetic energy is given. Then whether it is the same as that of force, it is not anyway, it is not equal to force. Why? Because force into acceleration into distance is will give the energy. Therefore, that is wrong. Or kinetic energy, you can say half mv square also, right? That also you can, so it will give the same result, same dimension it will give. Then work and energy are the same. Therefore, work also will give the same dimension. So work and energy are the same. Okay, so the answer is actually work. Work is actually, you will get the same dimensions. Okay, now next question. Which of the following pairs of physical quantities have the same dimensional formula? Torque and power, force and impulse, surface tension and energy gradient, pressure and stress. First, let us check one by one. Pressure. Pressure is actually, we know, force per area. is equal to ml t raised to minus 2 by L square is m L raised to 1 t raised to minus 2. Then let us see stress. Stress is actually again force per area is give the same dimension. Therefore, pressure and stress will give the same dimensions. This pair D. Let us see the other also, torque. Torque is actually having the same dimension. I mean, the torque is force into distance. It will give the dimension of the work. Okay, force, work, energy, and torque is having same dimensions. Then force we know is ml t raised to minus 2. It is not the same. Then impulse, force into time, ml t raised to minus 1. The surface tension is force by length, ml t raised to minus 2 by L is m t raised to minus 2. Mg gradient is mg per distance is actually ml t raised to minus 2. Therefore, only the pressure and stress are having the same dimensions. Okay, next one, the velocity of light. Velocity of light is equal to gravitational constant G and Planck's constant H are chosen as the fundamental units. Now we are taking 3 fundamental units. One is velocity of light C, second is gravitational constant G, third is Planck constant H. If these are taken as the fundamental quantities, then the dimensions of the mass in the system would be. That's what the question is. How we will find out? First, actually, what we will do, we will look at this. Okay, velocity of the light, then we have to find out the mass. So let us assume that mass is proportional to, okay, velocity of light raised to a, then gravitational constant, gravitational constant G, okay, raised to B, then Planck constant C. If that is the case, we can see here, let us find out the dimension of each of these quantities. Velocity we know, ml t raised to minus 1. So G we have to find, because G is F is equal to, okay, F is equal to G m1 m2 by r square. So for G is equal to F r square by m1 m2. So F we know ml t raised to minus 2, and then r square is L square, then m1 into m2 means actually m square. So we will get L raised to minus 1, L raised to 3, t raised to minus 2. Okay. So we know that G is equal to F r square divided by m1 m2, which will give ml t raised to minus 2 into L square divided by m square. That is actually, we will get m raised to minus 1 L cube t raised to minus 2. Then again, then we have to find out that H, okay, energy is equal to H nu or HF, okay, H nu or HF. F is actually nothing but frequency. So which will give H is equal to E by F or E by nu. Okay. So I am writing F actually for your convenience. Okay. Or you can, or nu, you can write nu also. Okay. It will look like B. It's a Greek letter. So E energy B, you know, the ml square t raised to minus 2 divided by F is actually t raised to minus 1. Okay. F is nothing but 1 by t. F is equal to 1 by t, right? 1 by t. That is at t raised to minus 1. Okay. So t raised to minus 1. T raised to minus 1. So we will get actually m L square t raised to minus 1. Okay. So then we will substitute here. Dimension of m is equal to, okay, is proportional to, or m is equal to, both are correct. So c raised to a, g raised to b, then h raised to c. That is equal to L, C means LT raised to minus 1 raised to a, then G is equal to, we have got M L raised to minus 1, L cube T raised to minus 2 raised to B. Then Planck's constant is M L square T raised to minus 1, the whole raised to C. Which is equal to M means M raised to 1, L raised to 0, T raised to 0. Okay. So we will get m raised to yeah, here first quantity there is no m, second there is b is there. Okay. Okay, first m actually what we getting is m raised to here, oh, sorry, this is actually here it will come m raised to minus 1. G is actually m raised to minus 1. Okay, it is m raised to minus 1. We have written wrongly. Okay, m raised to minus 1 L cube. M raised to minus 1 L cube. Okay, so what we'll get is actually m raised to 1 is equal to, okay, m raised to minus b plus c. Then L raised to a plus 3b minus 2c. Okay. Then d raised to minus a minus 2b minus c. So what will we get? We will get here c minus b is equal to 1, which implies actually c is equal to b. Okay, now again a plus 3b plus 2c is equal to 0. Okay, a plus 3b plus 2c is equal to 0. Again we will get minus a minus 2b minus c is equal to 0. Now when we solve this actually we will get a is equal to half, b is equal to minus half, and c is equal to half. Okay. So you can put these values here. Okay. When you put these values here, what you will get? The equation is C we are giving value a is half, then b is equal to minus half. Okay. C is equal to half. That means CH square root of CH by G. What is the question? Okay, it's correct. So C raised to half, G raised to minus half, and H raised to half. C into a square root of C into H divided by square root of G. That is the answer. The density of a cube is determined by measuring its mass, and the length of its side. If the maximum errors in measuring the mass and length are 4%, 3% respectively, the maximum error in determining the density is, we will find out the maximum error in measuring the density. So we know that actually density is equal to mass per volume. Okay. So volume means mass per L, length cube. So when to find out the relative error or fractional error, so that means actually delta rho by rho into 100, okay, is equal to delta m by m, that is relative error of mass into 100, plus L cube is 3 into delta L by L into 100. So it is given delta m by m as 4%. Okay, and that of length is given as 3%. So it is 4 plus 9 will give 13%. So the answer is 13%. Next, the pitch of a screw gauge is 0.5 mm and there are 100 divisions on its circle scale. We know there's a screw gauge is there. Screw gauge, there's a circular scale is there. Okay, in that actual divisions are there. Then there is a main scale also is there. Okay, there will be main scale also. Okay, in this divisions are there. So there are 100 divisions on the circle scale and the pitch is 0.5 mm. Okay, we know that, so we have to find out the least count. We know that least count is equal to pitch divided by number of divisions of the circle scale. Okay, number of divisions on circular scale. Circular scale. That means least count is equal to pitch. What is the pitch given here? Pitch given is actually 0.5 mm divided by number of divisions 100. That is 0.005 mm is the least count. Okay. A physical quantity X is related to other physical quantities A, B, C and D as X is equal to C raised to 4 D raised to half A square B raised to 3 by 2 is equal to same as A square B raised to 3 by 2 C raised to 4 D raised to half. It's actually, it's a product. So we can write it like this. Now it is given the percentage errors are A percentage error is 1%, B is 2%, C is 3% and D is 4%. Therefore, we have to find out the percentage error in X. So delta X by X into 100 is equal to 2 into delta A by A, okay, into 100% plus 3 by 2 delta B by B into 100% plus 4 into delta C by C into 100% plus half into delta D by D into 100%. So it is given actually. What is A? A is 1%. 2 into 1% plus 3 by 2 into 2% plus 4 into 3% plus half into 4%. What will be the result? 2 plus 3, 2 and 2 get cancels, then plus 12 plus 2. So 5 plus 12, 17 plus 2, 19%. The answer. Okay, the answer is 19%. The dimensions of HC by 1 by epsilon 0 e square are, so A is equal to M0, L0, T0, B is equal to ML T raised to minus 1, C is equal to ML square T raised to minus 2, D and M raised to minus 1, L raised to minus 3, T raised to 4 A square. But epsilon 0 is the permittivity of free space, E is electronic charge, H is Planck's constant, and C is velocity of light. So let's see what is epsilon 0. So we know that F is equal to 1 by 4 pi epsilon 0 r square into Q1 Q2. Okay, or Q1 Q2, or you can say E square also. So Q is charge, therefore you can say E square also. Okay, so we can find out E square by epsilon 0 also. If you want, you can find it that way also. Directly you can find, or you can find epsilon 0 separately. But let us find out actually 1 by epsilon 0 is. From this we can find 1 by epsilon 0, 1 with E square, 1 by epsilon 0 into E square by epsilon 0. Directly we can find out. Okay, this is equal to epsilon 0 is there, then E square is there, then if you take actually 1 by epsilon 0 here, then it is f into r square by q1 q2. Okay, so f is equal to ml t raised to minus 2 into r square divided by q is equal to at whole square. So m l t raised to minus 2 l cube, l into l cube, then t raised to minus 2 here, then a raised to minus 2, t raised to minus 2. So, sorry, we made a mistake because already we had taken e square here. Therefore, it will be this q1 q2 is not required here. So we will write once more f is equal to 1 by 4 pi epsilon 0 r square into e square. So what we are going to find out is actually e square by epsilon 0. Okay, is equal to f into r square. So ml t raised to minus 2 into l square, it will give actually m l cube t raised to minus 2. Okay. So now we have to find HC. So H, we know that E is equal to H nu or F, whatever. So we will give H is equal to E by nu. See, E is equal to m L square t raised to minus 2 divided by t raised to minus 1. It will give that we will get actually m L square t raised to minus 1. So HC by 1 by epsilon 0, 1 mean E square by epsilon 0 is equal to H, we know that m L square t raised to minus 2 into C is velocity, is L t raised to minus 2 sorry, L raised to minus 1, sorry, minus 1, then E square by epsilon 0, we already we got actually m L cube t raised to minus 2, which will give m L cube t raised to minus 2. Here actually m L cube t raised to minus 2. Then H is actually m L square minus 1. Sorry, one mistake we made here. So it is t raised to minus 1, t raised to minus 1, t raised to minus 2, correct. Divided by m L cube t raised to minus 2. So we will get actually m raised to 0, L raised to 0, t raised to 0 is dimensionless. So the answer is actually A, m raised to 0, L raised to 0, t raised to 0 is dimensionless. Okay. If the units of force, velocity, and time are chosen as fundamental unit, then the units of mass will be. So the fundamental units chosen are force, velocity, and time. So we know that it's F is equal to ma. We have to find the dimensions of m. So m is equal to F by A. So F is the fundamental unit. A is, actually we know A is V divided by T. So V is the fundamental unit, T is the fundamental unit. So it is F into T V raised to minus 1. So Ft V raised to minus 1. So the answer is F V raised to minus 1 T B. B is the answer. Okay. So it can be done in another way also. So we can equate it actually that m is equal to F raised to A, V raised to B, T raised to C. Then if you if you substitute and for the powers A, B, and C, for m raised to A, L raised to A plus B, T raised to minus 2A plus B plus C, if you equate it to m raised to 1, L raised to 0, T raised to 0, then also you will get the same result. Okay. So the next question is, the diameter of a wire is measured using a screw gauge with the least count of 0.01 mm. The measured diameter is 3 mm. The correct representation of the thickness of the wire is, So since the diameter is given, okay, so the measured value is given to 2 decimal places. So it is least count is 0.01 mm, measured value is 3 mm. The error is equal to the least count of the measuring instrument, which is 0.01 mm. Therefore, the correct representation is the measured value plus least count. Okay, that is measured value is 3 and the least count is given not 1. So two decimal places will be we can give. So it will be 3.00 plus 0.01. We should have 2 decimal places only. That is actually the correct representation of the thickness. Now the number of significant figures in the number 0.00230500 is 1, 2, 3, 4, 5, 6. Okay, it will be 6 because the 2 leading zeros are insignificant, that we will not consider it. Okay, we know the rules for significant figures is non-zero digits are always significant, then zeros between non-zero digits are significant, then trailing zeros of the number contained in the decimal point are significant, then leading zeros are not significant. So hence the significant digits are 2, 3, 0, 5, 0, 0. Plus 6 significant digits. Now, next one is the dimensional formula for gravitational potential. So gravitational potential we know is actually V. Potential is actually V is work done per unit mass. Gravitational potential is actually work done per mass. Gravitational potential. So work done we know m L square T raised to minus 2 by okay, now by mass is m. So we will get actually m and m get cancelled, L square T raised to minus 2. Okay, this is the gravitational potential is actually work done per mass or energy per mass. Now, next question is the Planck's constant h, speed of light c, gravitational constant is g are taken as 3 fundamental quantities. Which of the following combinations have the dimensions of length? Okay. Now, let us consider we have to find the dimensions of length. So dimensions of length is proportional to okay h raised to a, then g raised to b, Planck's constant and gravitational constant, and c raised to 3, the velocity of light. Okay, so velocity of light, right? C. Yeah, Planck's constant, speed of light in vacuum, and gravitational constant. So we are equating to that. Then we know that first we will find the dimensions of all the 3. C we know Lt raised to minus is velocity, and h for finding out what we actually h is equal to hf or h nu whatever, then which implies h is equal to e by f, that is actually m L square T raised to minus 2 divided by T raised to minus 1. F is raised to minus 1, that is m L square T raised to minus 1. Okay, now g gravitational constant, g we know g is equal to f r square by m1 m2, which will give ml T raised to minus 2 into L square divided by m square, which will give m raised to minus 1 L cube T raised to minus 2. So if we are equating these, we will get left side will get, we are finding L. Okay, here m is 0, T is 0 is equal to, then h we have got h actually m L square T raised to minus 1 or raised to a, then g is m raised to minus 1 L cube T raised to minus 2 b into c is L T minus 1 raised to c. So if you equating, we will get actually is equal to m raised to a minus b L raised to 2a plus 3b plus c then t raised to minus a minus 2b minus 2c. So when you equate, you will get a is equal to half, b is equal to half, c is equal to 3 by 2. So h raised to a, g raised to b, c raised to c means h raised to half, g raised to half, c raised to 3 by 2 minus 3 by 2, which implies c is minus 3 by 2, okay, which implies square root of h g by c cube. Okay, c raised to minus 3 by 2 is actually c cube in the denominator. C cube denominator means c raised to minus 3 by 2. Okay, so let us see. The answer is hg by c cube. A is the answer. Okay. Let's see next problem. If in an experiment, the percentage errors in the measurement of quantities A, B, C are 1%, A is 1% error, 1%, B is 2%, C is 3%. Okay. If Q is equal to C A square B raised to 3 by 2, okay, then what is the maximum percentage in Q, error of Q? So delta Q by Q into 100 is equal to 2 into delta A by A into 100 plus 3 by 2 into delta B by B into 100 plus 1 into delta C by C into 100. So which implies 2 into 1% plus 3 by 2 into 2% plus 1 into 3%. So you will get 2 plus 3 plus 3. So you will get 8%. So you can see the same here. You are getting 8%. The dimensions of the quantity L by R, where L is the inductance and R is resistance, are the same as that of frequency, time period, energy, and power. So we know that inductive resistance XC, so XL is equal to omega L. Okay, that means which is dimensionally equal to resistance, inductive resistance. No, this is resistance only. So which means dimensions of L by R is equal to 1 by omega. Omega is nothing but 1 by t raised to minus 1. It's equal to t. That means time period. Okay. So L by R is equivalent to time period. So you can see that actually the dimensions of L by R is equal to time period. Okay. Next one. Or you can find it in other ways also, but the problem here is that this is a this is a multiple choice questions in which there is time is very important. So you may be able to do it as fast as possible. So for that you have to see the shortcuts. Okay, you can do it the other way also. If you want, you can find the inductance. You can find you find out the inductance, then find out the voltage and all. Then with that also you can find out the R resistance. The dimensions you can find out. Okay, for that you need B. Like that also you can find out in a very lengthy way, but you will get the result the same. So I am doing it in the shortcut way because we know that XC, so XL is the resistance, which is omega L. From that we can find out L by R. Okay, the question is only about L by R. Therefore we can find out L by R directly. Okay. Now, if the error in the measurement of radius of a sphere is 2%, then what is the error determining the volume of sphere? So the question is volume of sphere, error in volume of sphere. Volume of sphere, we know what is the formula? 4 by 3 pi r cube. So here given R, delta R by R is given as 2%. So volume delta V by V into 100%, 100 is equal to 4 by 3 pi R cube. So 3 into delta R by R into 100 is equal to 3 into 2%, which will give 6%. Okay. Now the number of significant figures in 0.200 10 raised to 3 is actually significant figures 3. Okay, it's very clear. There is nothing to explain there, because there actually after the point there are 3 places. So all the 3 places after the decimal point is significant. Power has nothing to do with this. Okay, the significant figures will be 3. Now the dimensions of magnetic field B in terms of fundamental quantities mass, length, time, and current R. So we have to find the magnetic field B. So we know that the formula F is equal to IL B sin theta. Okay, BIL sin theta. Okay, from this we can find the magnetic field B is equal to magnetic field B is equal to F by IL sin theta. Okay, that means ML T raised to minus 2 divided by sin theta has no dimensions. So I is A, L is L itself. Therefore it is M, L and L get cancels. M T raised to minus 2, A raised to minus 1. Okay. So the answer is the dimensions M T raised to minus 2, A raised to minus 1. That is the answer. C is the answer. A quantity F is given by F is equal to square root of XC divided by Y square, where X has the dimensions of force, Y is dimensions of length, C has dimensions of velocity. So we have to find the dimensions of F. Okay. So it's given F is equal to square root of SC by Y square. Okay. So X is given force, C is velocity. So Y is length. Okay. So in that case, F is equal to square root of SC. X is actually force. Force is ml T raised to minus 2. Okay. Raised to half. Square root when change in powers, it is half. Okay. Then C is LT raised to minus 1. Half. Okay. Divided by Y square, L square. So if you multiply this, M raised to half. Okay. Then L raised to half, and L raised to half means L raised to 1. Then T raised to minus 1, T raised to minus half mean T raised to minus 1 minus half will give, what will get, minus 3 by 2 divided by L square. So M raised to half, L square when goes up it will be L raised to minus 2. So L raised to 1 and L raised to minus 1 will give L raised to 1 minus 2 will give L raised to minus 1. Okay, into T raised to minus 3 by 2. M raised to half. Okay, see here the answer is M raised to half, L raised to minus 1, T raised to minus 3 by 2. The answer is B. Okay. Okay. Now, the dimensions of thermal conductivity K are given by ml T raised to minus 3, K raised to minus 1. If the distance, okay, now given K thermal conductivity given by dimensions given by ml T raised to minus 3, K raised to minus 1. If the distance X is measured in centimeter, okay, thermal conductivity K, since X is measured in centimeter, time in T seconds, and temperature in T in Fahrenheit, what will be the value of thermal conductivity in the new system of units? We have to find out the new system of units. Okay. If its value in the SI system is KSI, in a system is KSI. Now it is given in a system of KSI is already given. This is the dimensions. Now if it is changed, okay, ml t raised to minus 3, okay, if distance is actually is measured in centimeter instead of meter, it is centimeter. Now in a system it is L is in meter, but now it is centimeter. Time is same in same seconds. Temperature instead of Kelvin, it is in Fahrenheit. So what will be the value of thermal conductivity in the new system units? Okay, that is the question. So we know that a system of units ml t raised to minus 3 k raised to minus 1. The new units actually length L dash we will say 1 centimeter, that is 10 raised to minus 2 meter. Okay. Now time we let us say t dash is equal to 1 second. There is no change in that. And temperature k dash instead of Fahrenheit, it is actually instead of Kelvin, it is in Fahrenheit. So when we change it actually degree Fahrenheit into Kelvin, it will be it will actually it is k dash is really 9 by 5 k. Okay, 1 degree Fahrenheit is equal to 1 degree Fahrenheit is equal to 9 by 5 k degree Fahrenheit. It is in k dash. So let's find out the ratio first. Ratio of actually x, let x be the ratio, and k nu, let k nu be the new thermal constant actually in the new units. Okay, then the thermal conductivity, let the new thermal conductivity be k nu, and the old one is KSI. So we'll find out the ratio of both. So how will we find the ratio? So now k nu into new units are m dash, l dash, t dash, because already it is given m, l dash, ml t raised to minus 3 k raised to minus 1. Therefore m dash, l dash, t dash into minus 3, then k dash raised to minus 1. Okay, divided by KSI. Okay, this divided by KSI into normal ml t raised to minus 3 k raised to minus 1. So let's write it like that. When you convert it into new units, okay, so it is KS, when you convert this into KSI, it is m into m dash is actually, what is that, m into 10 raised to minus 2L. Okay, m into 10 raised to minus 2L. Then temperature, we know that T raised to minus 3 into 9 by 5 K raised to minus 1 time, there is no change, divided by KSI into ml t raised to minus 3 k raised to minus 1. Okay, so what will happen? It will get KSI get cancelled, then m l t raised to minus 3 k raised to minus 1 divided by m l t raised to minus 3 k raised to minus 1 into what is left, 10 raised to minus 2 into 9 by 5 raised to minus 1. This get cancels, then what you will get? 10 raised to minus 2 into 5 by 9. Okay, it's equal to 5 by 900. Therefore, ratio is 5 by 900. Okay, so that is the ratio. X is the ratio. So that is what the question is. Therefore, 5 by 900 is equal to K nu by KSI, which implies K nu is equal to 5 by 900 into KSI. So the ratio is 5 by 900. That is the ratio. That's what the question is. You can see the question. What is the question? Dimensions of thermal conductivity are given, and if the distance x measured in centimeter, time in seconds, and temperature in Fahrenheit, what will be the value of thermal conductivity in new system of unit if its value in a system is KSI? So it's 5 by 900 KSI. Okay. So the next question is, the radius of a sphere is given as r is equal to 2.5 plus or minus 0.1 centimeter. The percentage errors in the calculation of surface area and volume of the sphere. Surface area, we know what is surface area, 4 pi r square. And what is the volume? 4 by 3 pi r. Okay. In case of surface area, what happened? 2 into radius, delta r by r into 100. In this case, 3 into delta r by r into 100. So delta r we are given here, r is equal to 2.5 plus or minus 0.1. Okay. So we have got r, we have got delta r also. So in the first case, surface area, delta a by a into 100 is equal to 2 into delta r by r into 100, which means 2 into delta r is 0.1 by 2.15 into 100. So we will get 2 into 0.4 into 100, which is 8%. Okay. So in the second case, percentage in volume, delta v by v into 100, which will give 3 into pi r is 4 by 3 pi r cube. Therefore, 3 into delta r by r into 100, which will give 3 into 0.1 by 2.5 into 100, which will give 12%. So the answer is 8% and 12%. D is the answer. The dimensions of the quantity of epsilon 0 E square, where epsilon 0 is the permitted free space and E is the electric field, are the same as that of pressure, energy density, force, electric potential. So let us see what is electric field. Electric field E is equal to F by Q. Okay, it is the force per unit charge. So if we know ml square t raised to ml t raised to minus 2 force. Q is A into I. A into T. That means m L raised to 1, T raised to minus 3, A raised to minus 1. This is dimensions of E. Now, E square is equal to m square, L square, T raised to minus 6, A raised to minus 2. Now, epsilon 0 is equal to Q square by FR square, which implies S square T square by F is ml T raised to minus 2 into L square. Okay, which gives m raised to minus 1, L raised to minus 3, T raised to 4, A square. Therefore, epsilon 0 E square is equal to m raised to minus 1, l raised to minus 3, t raised to 4, a square into e square we already found here is m square, el square, t raised to minus 6, a raised to minus 2. That will give a square raised to minus 2 will go. Then m raised to minus 1 and m raised to minus 2 is m raised to 1, l raised to minus 3, and l square will give l raised to minus 7, t raised to minus 4, t raised to minus 4 will give t raised to minus 2. Okay, so we are getting half of epsilon 0 e square. Half we will not consider since this is a constant. The epsilon 0 e square only we will consider. So this is what we wanted to get. This is the dimension factor. Which dimension will give this? Pressure. Let us see pressure. Pressure is equal to F by A. F by A is equal to ml t raised to minus 2 by L square, which will give m L raised to minus 1 t raised to minus 2. Pressure is giving the same dimension. Okay, so pressure is one of the physical quantities which give the same dimension as half epsilon 0 e square. Okay, now this is one thing. Second thing is actually let us see energy density. What is energy density? Energy density is energy by volume. Okay, energy by volume. What is energy? It is nothing but work. So ml square t raised to minus 2 divided by volume is L cube. Again, we will get m L raised to minus 1 t raised to minus 2. Okay, this is also giving the same thing. Force anyway we will not go. It is m L t raised to minus 2. So force is out of the question. Now next one we wanted to check is electric potential. Okay, so electric potential. So we'll check electric potential if you want. Electric potential is, what is electric potential? Is V. What's V? V is equal to W by Q. Okay, V is equal to W by Q, and W we know that ml square t raised to minus 2 divided by Q is AT. So we will get m L square t raised to minus 3 a raised to minus 1. So that is also out of question. Okay, so we got two, pressure and energy density. These two things we is actually same as half epsilon 0 e square. Next question. The fundamental units are changed such that the unit of mass becomes 10 kg, then the unit of length becomes 1 kilometer, and the unit of time becomes 1 minute. Then the force of 1 Newton in this new system will be equal to how much? Is a question. So we know that 1 Newton is equal to 1 kilogram meter second raised to minus meter per second square. Okay, because force is equal to mass into acceleration. Acceleration is really m s raised to minus 2 and force is kilogram. So the new unit m dash is equal to 10 kg. Okay, then length L dash is equal to 1 kilometer is actually 1000 meter. Okay, then t dash 60 seconds, 1 minute, 60 seconds. Okay, so in this case we know that n1 u1 is equal to n2 u2. Okay, the two new units. So when n1 u1 is equal to n1 is equal to 1. Okay, unit is equal to Newton is equal to n2 into nu n2 into force. Okay, actually 1 Newton is equal to, it's a unit of the unit is actually, then the force of 1 Newton in this becomes, okay, so it's for force, the dimension is for force only. Okay, then do u2. So dimension is actually for force ml raised to minus 2. So n2 is equal to 1 actually kilogram by 10 kg. Okay, into 1 meter. Okay, meter by 1000 meter into 1 second by 60 second raised to minus 2. Okay, so what we will get, 10 raised to minus 1, kilogram cancels, meter is actually into 10 raised to minus 3. Okay, meter get cancels, then actually 1 by 60 square means 1 by 60 into 1 by 60 power raised to minus 2. So it is equal to 3600 into 10 raised to minus 4, which will give 3.6 into 10 raised to 1 new units. Okay. So you will get 3.6 into 10 raised to minus 1 new units of force. If next question, the fundamental units are changed such that the unit of mass becomes 10 kg, unit of length becomes 1 kilometer, and unit of time becomes 1 minute, then the energy of 1 joule in this new system will be equal to. So energy, we know that energy ml square t raised to minus 2. So energy is m l square t raised to minus 2. Okay, that is called energy. So n1 u1 is equal to n2 u2. Okay, is equal to so that is actually 1 joule. Okay, so n2 will become n1 into u1 by u2. Okay, so which implies n1 into u1 is kilogram, new units is 10 kg. Okay, into 1 meter by 10,000 meter. Okay, so ml square, we are taking L, so this L square, this for m, this for L square, then t raised to minus 2. It is 1 second by 60 second by minus 2. So it's for energy. So what you will get? You will get 1 into n1 is 1. So 10 raised to minus 1 into 10 raised to minus 6 into 60 raised to minus 2. So you will get 3600 into 10 raised to minus 7, which is equal to 3.6 into 10 raised to 4 new units. Okay, these new units. Okay. Next question is the number of significant figures in the measurement of 0.02030 meter square is. So the zeros before, zeros before the non-zero and after the non-zero figures and after the decimal is insignificant. Therefore, we can consider 4 significant numbers. 2, 0, 3, 0 are significant, and the 0 after the decimal point, okay, is not significant. Therefore, there will be only 4 significant figures. So dimensions of the angular momentum are the same as that of. So let us see what is an angular momentum. Angular momentum, we know the formula for angular momentum is equal to L is equal to I omega. I is moment of inertia, which is actually mr square into angular momentum is equal to V by R. Great. So R and R will get cancelled, is equal to M V R. Otherwise, we know that actually that I is equal to M L square and omega is equal to t raised to minus 1. Okay, it's already t raised to minus, therefore M L square t raised to minus 1 of, or with MVR also you can find out MVR is equal to M into V L t raised to minus 1 into L. So it is actually M L square t raised to minus 1. Both ways you can get the dimensions of angular momentum. Okay. See, this ml square t raised to minus 1 is, we want to find out the dimension equivalent to the angular momentum. So work, anyway, we know work is actually m L square t raised to minus 2. So it is not same. So next is torque. Torque is same as work. it is ml square t raised to minus 2 only. So this is not the same. So next is actually power. Power is actually work by time is equal to m L square t raised to minus 2 divided by t. That means m L square t raised to minus 3. L square t raised to minus 3. So that is not also correct. Okay. So next one is actually Planck's constant. Planck's constant is actually h is equal to E by F frequency. So m L square t raised to minus 2 by t raised to minus 1, which will give m L square t raised to minus 1. So it is equal to Planck's constant. So Planck's constant and angular momentum having the same dimensions. Okay. Okay. Next one, if the length of a simple pendulum measured as L is equal to 20.0 plus or minus 0.1 centimeter and time period measured t is equal to 0.9 plus or minus 0.02 seconds, the percentage error of the determination of G is equal to 4 pi square L by t square is. This is what we want to find out. Okay. So we wanted to find out the percentage error in G. G is the acceleration due to gravity. So delta G by G into 100 is equal to delta L by L into 100 plus 2 into delta T by T into 100. So it is delta L. L is actually 20 plus or minus 0.1. So 0.1 by 20 into 100 plus 2 into, okay, T. 2 in delta T. Delta T is 0.02 by 0.9 into 100. It will give 0.5 percentage plus 2 into 2.22 percentage, which is equal to 4.94, that is 4.9 percentage. So our answer is 4.9 percentage. Next one, the dimensional formula for impulse, the same as that of, what is impulse? Impulse is equal to force into time, that is actually ml t raised to minus 2 into t, that will give ml t raised to minus 1. Okay, so we want to find out which one is having the same dimension as impulse. So let us take first one is given is force. Force anyway it is not correct because force in time only will give impulse. That is wrong. The momentum is mass into velocity, that is equal to m, velocity lt raised to minus 1. So it is having the same dimension. And momentum is correct answer. Then energy we know ml square t raised to minus 2. So it will be L, power will be 2. Therefore that is wrong. Then power is energy by time. Therefore that's also not correct. The power is actually m L square t raised to minus 3. So that is also wrong. So only momentum will have the same dimension as impulse. Next one, the physical quantity P has dimensions m raised to a, L raised to b, t raised to c. Then the dimensional root of P will be. This is the question. The P is equal to given m raised to a, L raised to b, t raised to c. So square root of P will be m raised to a by 2. Okay, naturally. Then L raised to b by 2, t raised to c by 2. Okay. Then next one, the dimensions of the ratio of magnetic flux to the resistance R are the same as that of so we have to find out what is magnetic flux. Magnetic flux, what is magnetic flux? It's equal to B A cos theta. We have to find out B. F is equal to BQV, which implies B is equal to F by QV. Okay, is equal to F is M L T raised to minus 2 and Q is AT, B is equal to L T raised to minus 1. Okay, which will give MT raised to minus 2, A raised to minus 1. Now, we got the dimensions of B. So, phi is magnetic flux is actually B into A. Okay, cos theta, B A cos theta is having no dimensions, therefore B into A, therefore M T raised to minus 2, A raised to minus 1 into L square, which will give M L square T raised to minus 2, A raised to minus 1. Okay. So magnetic flux, the ratio of magnetic flux to resistance is same. Resistance we know V by I. V is equal to W by Q. So into I mean QI. W means ML square T raised to minus 2 by Q is AT into A. So what we will get? M L square T raised to minus 3, A raised to minus 2. This is resistance. So the ratio of magnetic flux resistance. Magnetic flux we received here, and resistance we received here. So magnetic flux M L square T raised to minus 2, A raised to minus 1 divided by M L square T raised to minus 3, A raised to minus 2. So M will get cancelled, S square also will get cancelled. Then A raised to minus 1 and A raised to minus 3. So what we will get is actually T into A. Okay. A raised to minus 2 goes up. It is A raised to plus 2 and minus 1 plus 2 is plus 1. Then T raised to minus 3 and T raised to minus 2, we will get A into T, which is nothing but charge. Okay. So charge. Q is equal to charge. So the answer is charge. It is equal to charge. A cube has a side of length 1.2 plus or minus 0.01 centimeter. Now, we have to find out the error limits for the volume of the cube. So here, we know that length is given as 1.2 plus or minus 0.1. Now, what is the volume? Volume is L cube, okay, is equal to 1.2 the whole cube, which is 1.728 centimeter cube. Now, the relative error delta L by L. Okay, the relative error is delta L by L. So let us see the relative error of the volume delta V by V is equal to 3 into delta L by L, as we know. So we know delta L is equal to 0.1 divided by 1.2, which is give 0.25. This is actually delta V by V. Therefore, we have to find out delta V. So we already found out. We already found out the volume we know. So delta V by 1.728 is equal to 0.25, right? So which implies delta V is equal to 0.25 into 1.728, which will give 0.432 centimeter cube. So delta V, we got at the absolute error, we got at actually 0.432. So let us see which one will give 0.438, 1.728 for 0.432 with the D result. I mean the option D will give the result. Okay, that is the answer. Next one. The dimensions of H by E, where H is the Planck's constant and E is the electronic charge, are the same as that of magnetic flux, electric field, and voltage unity. Now let us see. H is Planck's constant, E is charge. We know Q is equal to E, charge is equal to AT. Okay, no doubt in that. Now Planck's constant we know E is equal to h nu, which implies h Planck's constant is equal to E by nu frequency. Okay, so E is, we know, energy ml square T raised to minus 2 divided by T raised to minus 1. Frequency is T raised to minus 1. Therefore, ml square T raised to minus 1. Okay, so we got H also. Then H by E is equal to, there is some mistake here. It is actually H by E, not EH. H by E. Okay. So H by E. H is, you know, ml square T raised to minus 1 divided by E is a T. Therefore, ml square T raised to minus 2 E raised to minus 1. Okay. Now we want to find out the quantity having, or the physical quantity which is having the same dimension as H by E. So let us take one by one. Now first we'll take voltage into time. Voltage into time. Okay. So voltage, we know voltage is equal to W by Q. W by Q. W is nothing but work, ml square T raised to minus 2 by Q is AT. So what we will get? ml square T raised to minus 3 A raised to minus 1. So into time means it is T into T. Okay. So ml square T raised to minus 2 A raised to minus 1. It is the same as this E by H. Okay. Next one. Next one is magnetic field. Magnetic field B is equal to F by QV. Okay. So F, we know ml T raised to minus 1. Q is AT into T. So sorry, this V AT into V is velocity, LT raised to minus 1, sorry, LT raised to minus 1. So T raised to minus 1, T will get cancelled. So what we will get is actually L and L will also get cancelled. So M is there, then ml T raised to minus 2. Okay. Force is ml. We will write once more. FQ is equal to ml T raised to minus 2 force divided by charge is A into T, and V is nothing but velocity, LT raised to minus 1. Okay. So T raised to minus 1, T will get cancelled. M and L will get cancelled when we get M T raised to minus 2 A raised to minus 1. Okay. This is not the same. Not same. This is not the one. Okay. Now, next one is magnetic flux. So magnetic flux phi is equal to B into A, and B we know, just now we found out, M T raised to minus 2 A raised to minus 1. A is L square. Okay. So it is M L square T raised to minus 2 A raised to minus 1. And so again it is the same, ml square T raised to minus 2 A raised to minus 1. So electric field. Yes, electric field. Electric field E is equal to F by Q. Okay. That is ml T raised to minus 2 by AT, which is ml T raised to minus 3 A raised to minus 1. Okay. This is not the one. Therefore, So we got magnetic flux and voltage indicate. Okay, the two of these quantities are equal to E by H. Okay, in dimensional formula. Next question. In a screw gauge, the zero error is 0.03 mm. While measuring the diameter of a wire, the main scale reading is 3 mm. Circle scale reading is 35 divisions. The least count of the screw gauge is 0.01. The correct diameter of the wire is okay. So what is given is actually main scale reading. We are given MSR 3 mm. Then circle scale reading is given 35 divisions. The least count is equal to given. Least count of the screw gauge is given 0.01. So we know that measured diameter is equal to MSR plus circle scale division into least count. That is 3 mm plus 35 into 0.01 mm. That is 3.35 mm. Now, zero error is given as 0.03 mm. So the correct diameter is actually measured diameter whatever minus the zero error. 3.35 minus zero error is 0.03 minus the zero error 0.03 into 3.32 mm. Okay. Next one is the dimensions of 1 by mu 0 epsilon 0, where mu 0 is the permeability of free space and epsilon 0 is the permittivity of the free space, are the same as that of. So we know that velocity of light c is equal to 1 by square root of mu 0 epsilon 0, which implies c square is equal to 1 by mu 0 epsilon 0. Okay. So what is mu 0 epsilon 0? Where mu 0 is the permittivity of free space, then the same is that the velocity c. See, the answers are velocity, acceleration, velocity square, acceleration square. Now what we got is actually velocity square. So this is the answer. Velocity square is equal to c is the velocity of light in vacuum. Now the number of significant figures in the number 23.023 into 10 raised to minus 5 is, now there is, we know that nothing to do with the power. Okay, now only this we have to consider. Significant figure is actually 23.023. There are 5 significant figures are there. Now the dimensions of the ratio of speed of light in vacuum to speed of light in medium, that is refractive index. So refractive index is actually, it is very clear actually, it is a ratio of 2 speeds. So naturally there is no unit for that, and actually there is no dimension also for that, okay, because it's a ratio of the same type of physical quantity. So both the dimensions will get cancelled, then it is actually dimensionless. So the answer is m raised to 0, l raised to 0, t raised to 0. Now the length of time period of a simple pendulum have errors 1%, 2%, 1% and 2%. Length and time period. Length has an error of 1%. Okay. Then time period has an error of 2%. Then the percentage error in the acceleration due to gravity g determined using t is equal to 2 pi root of L by g. So we know that t is equal to, it's given 2 pi into root of L by g. So t square is equal to 4 pi square L by g. Okay. So we want to find out the error, percentage error in due to acceleration to gravity. Therefore, which implies g is equal to 4 pi square L by t square. So delta g by g into 100 will be delta L by L into 100 plus 2 into delta T by T. Okay, so it will be delta L by L is given 1% plus delta T by T is 2%. So it will be 5%. Okay. The dimensional formula of the universal gas constant R. Okay. So we have to find out the dimensional formula for universal gas constant. So we know that the ideal gas equation is actually PV is equal to nRT, where P is the pressure, okay, pressure, then V is volume, then T is temperature, okay, temperature, and N is the number of moles, okay. So R is the universal gas constant. The PV is equal to nRT means is equal to nRT, which implies R is equal to PV by NT. Okay. So P is pressure. Pressure we know ml square. Okay. Force by area. Okay. We'll do it this way. Into volume we know L cube. Okay. Now N is actually mole. Sorry, MOL mole. Then T is actually Kelvin. Okay. So F by A we will find out. So it is actually M L T raised to minus 2 divided by L square. Okay. What is it? This is actually pressure. It's equal to M L raised to minus 1 T raised to minus 2. Okay. So R will be M L raised to minus 1 T raised to minus 2 into L cube divided by M mole Kelvin. Okay. So what will you get? M L square T raised to minus 2, okay, divided by, into mole raised to minus 1, K raised to minus 1. ML square T raised to minus 2, K raised to minus 1, mole raised to minus 1. So this is the answer. The answer is A. M L square T raised to minus 2, K raised to minus 1, mole raised to minus 1. That is the answer. Next one. A thin wire has length of 21.7 plus or minus 0.01 centimeter and radius of 0.46 plus or minus 0.01 mm. The percentage error in the calculation of the volume of the wire is. So we have to find out the percentage error in the volume of the wire, because this is actually a cylindrical shape. So it's a wire, okay, it is a cylindrical shape. So what is the volume of cylinder if the area is pi r square and this is length is L? Okay, it will be pi r square L, area into length. Okay, this is the volume of cylinder. So volume of the wire. Volume of the wire. What is the volume of the wire? Pi r square L. So percentage error in volume is equal to delta V by V into 100. Okay, what will give? 2 into delta R by R. Pi is a constant we will not consider. Okay, then actually 2 into delta R by R plus delta L by L is equal to 2 into 20 radius. Radius is equal to, what is the radius? Radius 0.46 plus or minus 0.01. So delta R by L. 2 into delta R is 0.01. Okay, divided by 0.46 into 100. Okay, plus length. What is length? 21.7 plus or minus 0.1. Therefore, 0.1 by 21.7. Okay. Into 100. So you will get 2 into 2.17% plus 0.46%, which will give 4.8%. If you see that, the answer is C, 4.8%. Next one. A student performs an experiment to determine the Young's modulus Y. Otherwise, the formula used is Y is equal to Young's modulus. What is the formula for Young's modulus? Y is equal to F into L divided by pi R squared delta L. Okay, this is a small change. Okay, this is a small change. So this is actually force length by small change. So actually it is stress by strain. Stress is actually F by A. Okay, divided by strain. Strain is actually L, delta L by L. Okay. Or F by A is actually pi R squared. That's all. This is what it is actually. Okay. So this is how it will come. So the percentage error, if you are calculating, it is given actually a student performs an experiment to determine the Young's modulus. The formula is given. F is the force, L is the length, R is the radius, delta L is the extension. If the percentage error in force, length, radius and delta L R, the things are given. For F, percentage error is given. For force, 1%. Okay. Then for L, it is 2%. Then for R, it is 3%. Okay, R it is 3%. And for delta L, it is 4%. So delta Y by Y into 100, okay, delta Y by Y into 100 is the maximum percentage error in Young's modulus, is equal to delta F by F into 100 plus delta L by L into 100 plus 2 into delta R by R into 100 plus delta of delta L delta L by delta L. Okay, delta L by delta L. Okay, delta L by delta L into 100. So what you will get? You will get 1% plus 2% plus 2 into 3% plus 4%. So the answer is 13%. Okay. The dimensions of the coefficient of viscosity eta are. So we have to find the coefficient of viscosity, the dimensions for coefficient of viscosity. So we know that viscous force F is equal to eta into area into velocity gradient dV by dx. Okay, So coefficient of viscosity eta is equal to F divided by A dV by dx. So F we know mLT raised to minus 2. Then A is L square. Then dV by dx is equal to LT raised to minus 1 by L. Okay. So this L and L will get cancelled. Okay. Then what you will get? M L raised to minus 1. Then T raised to minus 1. Okay. So the answer is A. M L raised to minus 1, T raised to minus 1. Okay. Now, a physical quantity is given by x is equal to a square b cube by c square root of d. Okay. If the percentage errors A, B, C, D are, the percentage error for A is alpha percentage. Then for B it is beta percentage. And C, it is gamma percentage. And for D, it is delta percentage. If this is the case, what is the maximum percentage error of x? So delta x by x into 100 is equal to 2 into delta A by A plus 3 into delta B by B plus delta C by C plus half into delta T by D. Why it is half? Because it is actually square root of D. Square root of D means D raised to half. Okay. So it will be 2 into 1 percentage plus 3 into 2 percentage plus 3 percentage plus half into 4 percentage. So it is 2 plus 6 plus 3 plus 2 percentage. Okay, total means 8 plus 3, 11 plus 2, it will be 13 percentage. Okay, but actually no, it is not, sorry, it is not 1 or 2, it is actually alpha, this is beta percentage, this is actually gamma, this is delta. It is not 1, 2, 3, 4, it was for the previous question, it was from, therefore it is 2 alpha plus 3 beta plus gamma plus 1 by 2 delta percentage. So the answer is A. We get 2 alpha plus 3 beta plus gamma plus 1 by 2 delta percent. Okay, that is the answer. The dimensions of electrical resistance are, so we have to find the dimensions of electrical resistance. Okay, so what is electrical resistance? Electrical resistance is equal to V is equal to IR, that means actually V by I is equal to R. Okay, so R is equal to V by I. So V is equal to W by Q into I. Now W by V is B, so V by I is equal to W by QI. W is actually nothing but work. Work is actually, we know, ml square T raised to minus 2 divided by Q is equal to A into T, again A. Okay, I is A. Okay, so what we will get? L square T raised to minus 3, A raised to minus 2. Okay, this is the dimensions of resistance. Next one, if the unit of force is 100 Newton, unit of length is 10 meter, and unit of time is 1 second, then the unit of mass in the system. So we know that F is equal to M into A. So it's equal to M into A A is velocity by time, or m into length by time square. So 100 Newton, okay, is equal to m into 10 meter by seconds, 1 second square, which implies 100 kilogram meter second raised to minus 2 is equal to 10 meter m into 10 meter second raised to minus 2. Okay, so meter second square minus square get cancels, then m is equal to 100 by 10 is equal to 10 kg. Okay, next is the dimensions of pressure gradient. Pressure gradient is actually pressure divided by distance. Okay, so is equal to dp by dx. Okay, change in pressure by distance. So pressure is actually F by A into distance. So it is actually m L T raised to minus 2 into L cube. That is actually m L raised to minus 2 T raised to minus 2. Next one is a Vernier caliper. Main scale division is x centimeter, and n divisions of the Vernier scale coincide with n minus 1 divisions of the main scale. Least count of the Vernier caliper in mm. So we know m must is x centimeter. So n times Vernier scale division is equal to n minus 1 MSD. So 1 VSD is equal to n minus 1 into n minus 1 divided by n centimeter. So least count, we know that main scale division, 1 main scale division minus 1 VSD, that is x minus n minus 1 by n x. So we will get x by n centimeter. To convert it into millimeter, you have to multiply it by 10. The dimensions of latent heat. So latent heat, we know latent heat L is equal to heat, okay, or Q divided by mass. So Q is nothing but energy, heat energy. Energy is ml square T raised to minus 2 by m. So it will be L square T raised to minus 2. Next is dimensions of Boltzmann's constant. So Boltzmann's constant, we can find out from Stefan's law. Stefan's law says actually E is equal to sigma T raised to 4. Okay, where E is the energy radiated per unit area per unit time, and that is power per unit area. Okay, then sigma is the Boltzmann's constant. So E is equal to the energy radiated per unit area per unit time. Okay, that means m L square T raised to minus 2 divided by L square into time. Okay, unit area unit time divided by energy per unit area unit time. That is L and L will get cancelled, then m T raised to minus 3. Now T T raised to 4 is equal to temperature 4 raised to 4, that is Kelvin raised to 4. Therefore, Boltzmann's constant is equal to E by T raised to 4. E is mt raised to minus 3 divided by K raised to 4. So it is m T raised to minus 3 K raised to minus 4. In a spherometer, the least count is 0.005 and the number of divisions on the circular scale is 100. The pitch of the screw is. The spherometer is an instrument like screw gauge, but it is used for measuring the for measurement in curved surfaces. Okay. So least count, we know least count is equal to given 0.005 centimeter. Okay. Number of divisions in the circle scale is 100. Number of divisions is 100. So a spherometer is specially designed to measure the radius curvature of spherical surfaces, while screw gauge is used to measure diameter of thickness of small objects. So least count, we know least count is equal to pitch divided by number of divisions. Okay, pitch is actually, so therefore pitch is equal to, which implies pitch is equal to least count into number of divisions. So least count is given as 0.005, number of divisions is 100, therefore the answer is 0.5 centimeter, which is the pitch. Okay, the pitch of the screw is to be found, we have to find the pitch of the screw. The pitch of the screw is 0.5 centimeter. The dimensions of electric dipole moment are. So what is electric dipole moment? Electric dipole moment. What is electric dipole moment? Electric dipole moment P is equal to charge into distance. It's equal to Q into D. Okay. Q is, we know, A into T. This is L. So it's equal to dimensions ATL. Okay. So answer is A. Next is the error in the measurement of momentum of particle is 2%. So error in momentum P, error in momentum P. Okay, error. So the error in momentum is 2%. How much is 2%? Now the error in the measurement of mass. Error in mass is 1%. Okay. So the maximum error in the measurement of its kinetic energy. So we know that kinetic energy is equal to P square by 2m, where P is momentum. Okay. And M is mass. So percentage error in kinetic energy is equal to, okay, delta Ke by Ke into 100. It's equal to 2 into delta P by P plus delta M by M. Okay. That is delta P is 2%. 2% plus delta M 1%. 1%. 2 into 2% plus 1%, this means 5%. The answer. Next is dimensions of magnetic permeability, mu. Dimensions of mu. So we know that F by L is equal to mu 0 I1 I2 divided by 2 pi d. Okay. So mu 0 is equal to F into 2 pi d divided by I1 I2 into L. If we know that ml t raised to minus 2 into d is L again, then I1 I2 A A square, then L. L gets cancelled, then ml t raised to minus 2, a raised to minus 2. The answer. Okay. Magnetic permeability. Now the significant figures 6.023 10 raised to 23. So 10 raised to 23 is the power has no significance here. Therefore, there is 6.023 only to consider. That means the significant figures is 4. Next is the dimensions of gravitational intensity. So gravitational intensity Ig is equal to gravitational force per unit mass. So we know that force is m1 t raised to minus 2 by m, it is L t raised to minus 2. So it is L t raised to minus 2. Now, the length of a rod, 3 plus or minus 0.1 centimeter, and radius is 0.05 plus or minus 0.001 centimeter. Then the percentage in the volume. So V is equal to, since it's a cylindrical shape, it is pi r square L. Okay, pi r square L. So delta V by V percentage is equal to 2 into delta R by R into 100 plus delta L by L into 100%. So how much will come? So 2 into delta R by R is 0.001 by 0.05 plus 0.1 by 3 into 100 into 100. So it will be percentage base, we are taking 2% plus 3.33%. So 2 into 2%. Okay, that means 7.333%, which is 7%. Okay, the answer is 7%. The dimensions of magnetic susceptibility. So we have to find out the dimensions of magnetic susceptibility. So magnetic susceptibility, gamma m is equal to magnetization m divided by magnetic field intensity. Okay, m by h. Now what is magnetization? Magnetization, m is the magnetic moment per volume. So magnetic moment is nothing but the product of current I into area. Okay, so divided by magnetization is IA by volume. So it is A L square area. Okay, A is current, divided by volume is L cube again. So it will be A L raised to minus 1. So magnetization is A L raised to minus 1. Now magnetic field intensity H is equal to current per unit length. Okay, that is A by L is A L raised to minus 1. So the ratio of susceptibility is the ratio of M and H. That means A L raised to minus 1 divided by A L raised to minus 1. That means it is dimensionless. The dimensions of Rydberg constant are. So we know that Rydberg constant. Okay, so 1 by lambda is equal to Rydberg constant into 1 minus n1 square minus 1 by n2 square, where n1 and n2 are the principal quantum numbers and lambda is the wavelength. So Rydberg constant is equal to 1 by lambda into 1 by n1 square minus 1 by n2 square. This terms is dimensionless. This term is dimensionless. So lambda is the wavelength. That is actually 1 by L. That means L raised to minus 1. So the dimension of Rydberg constant is L raised to minus 1. Okay. A screw gauge has a pitch of 0.5 mm and 50 divisions on its circle scale. When a glass plate is inserted between the jaws, when the thickness of the glass plate is to be measured, the main scale reading is 2 mm and circle scale reading is 30 divisions. So the thickness of glass plate is, so we know that pitch is given us 0.5 mm and circular divisions is number of circular divisions 50. So we know that least count is equal to pitch by number of divisions is 0.5 by 50 is 0.01. So main scale reading is 2 mm, then circular scale reading is 30 division, then thickness of the glass, how we will find out MSR plus CSR into LC. So 2 plus 30 into 0.01 is equal to 2.3 mm. Okay. Now the dimensions of magnetic flux density are the same as that of. So we should find out the dimensions of magnetic flux density first. So magnetic flux density for finding out magnetic flux density, we have the equation F is equal to I L B sin theta, and sin theta we know that it is not having any dimensions. Therefore magnetic flux density B is equal to F by I L. Okay, is equal to M L T raised to minus 2 by A L. It's equal to L will get cancelled. M T raised to minus 2, A raised to minus 1. Okay. So we got the dimensions of magnetic flux density. Now we have to check actually if any one of these specific these physical quantities have dimensions similar to same as magnetic flux density. Okay. So magnetic flux, we know magnetic flux is phi is equal to B into magnetic flux density into area. Okay. So magnetic flux density into area means M T raised to minus 2 A raised to minus 1 into L square. So it is M L square T raised to minus 2 A raised to minus 1. Okay. So it is not matching. Next one, magnetic flux, then mu0. Mu0 is equal to 1 by C square epsilon 0. That means permeability free. We have to find out permeability of free space. Okay. So we know mu0 is, that means C square is equal to 1 by mu0 epsilon 0, which implies mu0 is equal to 1 by C square epsilon 0. Let's first see what is epsilon 0, the permittivity of free space. Okay, then permittivity of free space epsilon 0 is equal to 1 by 4 pi FR square into E square. Okay, so 1 by F is actually M L square T raised to minus 2 into L square, E square is actually A square T square. Okay, so what we will get actually M raised to minus 1, L raised to minus 3, T raised to 4, A square. Now mu0 is equal to 1 by C square epsilon 0 means 1 by L T raised to minus 1. C square is nothing but the velocity of the light. Therefore L T raised to minus 1, distance by 10. Okay, the whole square epsilon 0 we got M raised to minus 1, L raised to minus 3, T raised to 4, A square. A square. Okay, so what we will get? We will get mu0 is equal to M L T raised to minus 2, A raised to minus 2. Okay. Now next one is permeability phases will be found out pressure, then force per unit pressure, then force per unit length per unit current. Next one is pressure. So we have to check actually whether it is matching with magnetic flux density m t raised to minus 2 a raised to minus 1. Okay, m t raised to minus 2 a raised to minus 1. Okay, this is what we are checking. So next one is actually pressure. Pressure is, you know, F by A is equal to ml t raised to minus 2 by L square is actually m L raised to minus 1 t raised to minus 2. Okay. Next one is force per unit length per unit current. Force per unit length per unit current. So m L t raised to minus 2 by L A. So L will get cancelled. Then m t raised to minus 2 m t raised to minus 2, then force per unit length per unit current. Okay, m t raised to minus 2 a raised to minus 1. Okay, so B, dimensions of B, 1 second, let me check. B is, yeah, m t raised to minus 2 a raised to minus 1. Okay, this is matching with that. Okay, so when we have written there, we have done it wrongly here. I think this is minus 1. Okay, so it is matching with the force per unit length per unit current is matching with the flux density. Okay, not flux density, it is the it is the flux density, sorry, with the magnetic flux density. Okay, magnetic flux density m t raised to minus 2 a raised to minus 1. Same, it is same as the force per unit length per unit current. Okay, correct. Now next is the number of significant figures in the result of the multiplication 3 into 0.0069. So what we are getting when multiplying is actually here the number significant is actually here the first case significant figure, the lowest significant figure is actually 2. Okay, so you should have the when you multiply this also you have to get only 2 significant figures. Therefore, the answer is A. Now the dimensions of impedance. So impedance will have the dimensions same as resistance. Impedance can be, it can be inductive impedance XL or capacitive impedance XC. Okay, so whatever be the case, it is equivalent to resistance. So the dimension will be same as resistance. Now, next one is the dimensions of power. The dimensions of power are same as that. What is the dimension of power? Power is actually work by time. Okay, so it is m L square t raised to minus 2 by T is m L square t raised to minus 3. Okay, this is actually power. Now, force and velocity is equal to ml t raised to minus 2 into L t raised to minus 1 is equal to m L square t raised to minus 3. Okay, it is both are same. Okay, now force and displacement. Force and displacement is actually that will not give the same result because already displacement is L only. We have considered velocity here, therefore that will not come since it is such positive velocity, displacement is ml square t raised to minus 2. Okay, so it is nothing but the energy or work. Then energy per displacement. Energy per displacement also, energy means ml square t raised to minus 2. By displacement is such, it will give m l t raised to minus 2. So it is not matching with this. Then momentum into acceleration. Momentum into acceleration. Momentum into acceleration is actually momentum is actually mv, m into l t raised to minus 1. Okay, acceleration is l t raised to minus 2. So it will give ml square t raised to minus 3. So that is matching with this. Ml square t raised to minus 3. Okay. The vernier caliper has 10 divisions on its vernier scale that coincide with the 9 divisions on the main scale. If each division on the main scale is 1 mm, the least count of the caliper is. So we know that actually 10 vernier scale division is equal to 9 MSD. Okay, it is given. So 1 BSD is equal to 9 by 10 MSD. So 9 by 10 into 1 mm is 0.9 mm. The least count is actually 1 MSD minus 1 BSD. So 1 mm minus 0.9 mm means 0.1 mm. Now, the density of a material in CG system is 4 gram per centimeter cube. Then the density in SA system is, okay. So we know that the density is equal to given 4 gram per centimeter cube. So when it is changed in a system, gram will change into kilogram. So 4 gram means actually 1 by, when gram is converted into kilogram, we divide by 10 cube, okay, by 1000. Okay, so much kilogram, then divided by centimeter cube, means centimeter is to be converted into meter, so the whole cube, so much meter. Okay, so much meter. So what you will get? So 4 into 10 raised to minus 3, okay, divided by 4, divided by 10 raised to minus 6. So it will be 4 into 10 cube, okay, 10 cube kilogram per meter cube, that is 4000 kilogram per meter cube. Now the dimensions of, next question is dimension of E square by 4 pi epsilon 0 r. So we know that F is equal to E square by 4 pi epsilon 0 r square. Okay, so F into r is equal to E square by 4 pi epsilon 0 r square. It is equal to m l t raised to minus 2 into l is equal to m l square t raised to minus 2. It is nothing but work or energy. Work or energy. Okay. The dimensions of the quantity integral of E dl, where E is electric field and dl is the small length element, are the same as that of force, energy, potential, and power. So E into dl represents the negative, E dot dl represents the negative of the potential difference between 2 points in electric field. Therefore, dimensions are the same as that of electric potential. Okay. So let us see what is electric potential dimensions. So electric potential E is equal to F by Q, that is ml t raised to minus 2 into a raised to minus 1 t raised to minus, because Q is A into T. Okay, Q is AT. So when it comes up, it will A raised to minus 2, T raised to minus 2. Therefore, ML T raised to minus 3, A raised to minus 1. Okay, so voltage, if is electric potential voltage is W by Q is equal to M L square T raised to minus 2 divided by AT. So it is same as M L square T raised to minus 2 into AT voltage. That is M L square T raised to minus 3, A raised to minus 1. Now, E into DL is equal to M L square, sorry, ML T raised to minus 2, A raised to minus 1 into L. That is same as ML square T raised to minus 3. T raised to minus 3, A raised to minus 1. So both are same. Okay. E is equal to voltage. Okay. Next one, the percentage error in the measurement of resistance 2%. So percentage error is 2%, and that of current delta I is equal to 3%. Okay. The percentage error in the measurement of power. Okay. So delta R by R, delta I by R, I we got. Now power is equal to, power is I squared R. So delta P by P into 100 is equal to 2 into delta I by I into 100 plus delta R by R is equal to 2 into 3% plus 2 is equal to 8%. Okay. The dimensions of the quantity B square by 2 mu 0, where B is magnetic field. It's B square. Okay. Where B is the magnetic field and mu 0 is the permeability free space, are the same as that of pressure, energy, magnetic energy density, and force. So let us see B, as we are aware, B is equal to, okay, F by IL. You know that VIL sin theta is equal to F. Okay. So from that, V is equal to F by IL. So ML T raised to minus 2 by AL is equal to LL get cancels, MT raised to minus 2, A raised to minus 1. Oh, we got B. Now B square is equal to M square T raised to minus 2, A raised, so minus 4, A raised to minus 2. Okay. Now mu 0 is F into 2 pi D, okay, divided by I1 I2 L is equal to ML T raised to minus 2 into L by A square L. L get cancels, and we will get ML T raised to minus 2, A raised to minus 2. Okay. So B square by 2 mu 0 is equal to B square. We have got B square here. B square is actually M square T raised to minus 2, A raised to minus 2 divided by, sorry, T raised to minus 4. Minus 2 divided by mu 0. Mu 0 is equal to M L T raised to minus 2, A raised to minus 2. Okay. So what we will get, M square 1 m cancels here. Okay. Now A square get cancels. We will get M L raised to minus 1, T raised to minus 2, T raised to minus 2. Okay, what we are getting. So let us see what are the other things that can give the same dimensions. Pressure. Pressure is equal to force by area is equal to ml T raised to minus 2 by L square is equal to m L raised to minus 1 T raised to minus 1, giving the same dimensions of this. Okay. So energy, you know, energy is ml square T raised to minus 2, it's not the same. Okay. Then energy density. Energy density is actually energy by volume. It is actually m L square T raised to minus 2 by L cube. Again, you are getting m L raised to minus 1 T raised to minus 2. Getting same dimension here also. Okay. Next one. The dimensions of thermal resistance are. So let's see what's the thermal resistance. Thermal resistance RTH is equal to delta T by H, where delta T is the temperature difference and H is the rate of heat flow. Okay, H is rate of heat flow is dq by dt. Okay, dq means actually that energy ml square T raised to minus 2 by T means it is ml square T raised to minus 3. Okay, now delta T is nothing but K. Okay, change in temperature is Kelvin. So RTH is equal to delta T by H will give K divided by ml square T raised to minus 3. Okay, so what we will get, m raised to minus 1, L raised to minus 2, T raised to minus 3 and K. So L raised to minus 1, T raised to minus 3. Okay, here actually one mistake is there. It is T raised to minus 3. Okay. L raised to minus 2, T raised to minus 3K. Minus 3K. Actually, answer is actually minus 3K. Minus 3K. Answer is C, not A. Okay. This C. M raised to minus 1, raised to minus 2, T raised to minus 3K. Okay. Next one. If the length of a side of the cube is measured 2%, then error in the measurement of volume. So we wanted to find volume. Volume actually cube. The volume is actually L cube. Okay. Now delta V by V is equal to 3 delta L by L into 100. Okay. That is actually 3 into 2%. It will be 6%. The answer is 6%. Okay. Next is the dimensions of angular acceleration. So you want to find dimensions of angular acceleration. So angular acceleration alpha is equal to rate of change of angular velocity. Okay, rate of change of angular velocity. Okay, that is the angular velocity T. That is actually omega by T. Omega is equal to T raised to minus 1 divided by T. That means T raised to minus 2. Answer is T raised to minus 2. Now, a screw gauge has a pitch of 1 mm and 200 divisions of its circular scale. The least count of the screw gauge is, so we have to find the least count of the screw gauge. What is given is actually the pitch, okay, and the number of divisions. So this is a very simple one. Least count is actually pitch by number of divisions. Okay, number of divisions. Pitch is actually given as 1 mm divided by the difference 200. So the answer is actually 0.005 is equal to 5 into 10 raised to minus 3. Yeah. It's very simple. Okay. Next is the dimensions of the quantity half Li square, where L is the inductance and I is the current, are the same as that of. So half Li square represents the magnetic energy stored in the conductor. Now we know that half Li square is equal to the magnetic energy stored in inductor. Okay. So it is nothing but energy. So ml square T raised to minus 2 is actually nothing but energy. So the answer is energy. Number of significant figures in 2.030 in 10 raised to minus 3 is. So actually there are the power 10 raised to minus 3 is insignificant here. We will not consider that. If you consider the other thing, it is actually 2.030. There are 4 significant figures. 4. Okay. So the dimensions of the quantity B by I, which is nothing but resistance. Okay. So B by I is resistance. So it is the dimensions of resistance. If the radius of a wire is decreased by 0.1%, the percentage increase in its resistance is. So we have to find the percentage increase in resistance when radius is changed. The decrease by 0.1%. We know resistance is equal to rho L by A, where rho is, what is the rho? Is specific resistance. Specific resistance. Okay, that depends upon the material. Okay, L is the length, A is the area of cross section. In this case, actually, it is the radius given. Therefore, A will be pi r squared. It is actually it will be in the radius will be circle. Sorry, that area will be circle in shape because it is a cylindrical shape of wire. So the cross section area will be circular. Okay. So R square rho L by A. So therefore what happens? R is equal to rho L by pi r square. What this implies? Resistance is inversely proportional to R square. Okay. So percentage change in resistance, we have to find out. For that, how we will find delta R by R into 100. What you will get? 2 into percentage change in radius. Okay. Delta R by small r. This is radius. This is resistance. Capital R is resistance. Okay. It's equal to 2 into 0.1%. So it will be 0.2%. Now the dimensions of gravitational constant G. So we have to find G. So we know F is equal to G into M1 M2 by R square, which implies G is equal to F R square by M1 M2. F we know ML T raised to minus 2, R square is L square divided by M square. Okay, so it will be M raised to minus 1, T raised to minus 2, L square. So G will be M raised to minus 1, T raised to minus 2, T raised to minus 2, then M raised to minus 2 L square. Here something is wrong. M raised to minus 2. Okay. Actually, it is M raised to minus L cube. Okay, it is L cube. So one L is already there. This L is going up. Okay. So okay, this L is there. That means L cube. So M raised to minus 1, T raised to minus 2 L cube. is the answer. Okay. So next one, the dimensions of conductance. What is conductance? Conductance is actually reciprocal of the resistance. Okay, that is 1 by R. So conductance is equal to 1 by R. So R, let us see what is R. So dimension of R is equal to, we know W by Q, V by I. V by I, that means W by Qi is equal to, W is work ml square t raised to minus 2 divided by charge is A into T into A. So it will be ml square t raised to minus 3 A raised to minus 2. Okay. ml square t raised to minus 3 A raised to minus 2. Therefore, conductance is equal to 1 by R is equal to reciprocal of resistance. That means m raised to minus 1, L raised to minus 2, t raised to 3, A square. Okay. Next is, the mass of a body is measured by 10.0 plus or minus 0.1. Mass is equal to 10.0 plus or minus 0.1 kg. Okay. Velocity is 20.0 plus or minus 0.2 meter per seconds. Then the percentage error in determination of kinetic energy. So kinetic energy, we know kinetic energy is equal to half mv square. Okay. So percentage change delta Ke by Ke into 100 is equal to delta m by m into 100 plus 2 into delta v by v into 100. Okay. So change means 0.1 by 10. Okay. Point 1 by 10 into 100 plus 2 into delta V. Delta V is actually 0.2 divided by 20 into 100. So that will be 1%. Okay. 1% plus 2 into 1%. The answer is 3%. The dimensions of surface energy are the same as that of. So let us see what is surface energy. Surface energy is energy per unit area. Okay, so surface energy is equal to energy per unit area. So it will be, you know what is energy, m L square t raised to minus 2 divided by L square. So L and L will get cancelled. This m t raised to minus 2. This is actually surface energy. What is surface tension? Surface tension is actually force per unit length. Okay, surface tension is equal to force per unit length. So that will be ml t raised to minus 2 by L. So what you will get, m t raised to minus 2. So both are having the same dimensions. Again, we will see energy gradient. So energy gradient is the change in energy with respect to distance. So energy gradient is equal to energy per length. Okay, with respect to distance. So energy is, you know, ml square t raised to minus 2 divided by L. So that will be ml t raised to minus 2. It is not the same. Okay, it is equal to force actually. Then we have force per unit volume. So force per unit volume is, force is ml t raised to minus 2 divided by volume is L cube. So what we will get is m L raised to minus 2 t raised to minus 2. It is actually energy. Okay. Sorry, it is not energy. Energy is actually m ml square t raised to minus 2. This is m l raised to minus 2. This is not energy actually. It is m l raised to minus 2 t raised to minus 2. Now pressure. Pressure is equal to force by area is equal to m l t raised to minus 2 by l square is equal to m l raised to minus 1 t raised to minus 2. Okay. So that's also different. So what we are getting actually surface tension is the dimension of surface tension is same as surface energy. The dimensions of Poynting vector S is equal to 1 by mu0 into E into B are the same as that of. So we have to find out, first we have to find out the dimensions of Poynting vector. So Poynting vector S is equal to 1 by mu0 into E into B. Okay. So electric field, okay, and electric field density. So mu0 is the permeability of free space. So let us see, okay, and E is the electric field and B is the magnetic field. So E, the electric field, but let us first find the dimensions of electric field. E is equal to F by Q, okay, and F we know mLT raised to minus 2 by Q is A into T. Therefore, it is M L T raised to minus 3 A raised to minus 1. Okay. Now we know F is equal to BIL sin theta. In sin theta there is no dimensions. So B is equal to F by IL. F is equal to ML T raised to minus 2 divided by A into L. So L and L will get cancelled. Then M T raised to minus 2 A raised to minus 1. So we got the dimensions of A and H. Sorry, and E. Now mu0. Mu0 we know mu0 is equal to 2 pi F 2 pi RF or 2 pi DF divided by I1 I2 L. Okay, so the dimension is F is ML T raised to minus 2 into L. Okay, then divided by I1 I2 A square into again L. Both L will get cancelled. Then it is ML T raised to minus 2 A raised to minus 2. Okay. Now E into B will be, what is the E? E we got here ML T raised to minus 3 A raised to minus 1. Okay. And B we got here, what is the B? M T raised to minus 2 A raised to minus 1. Okay. So it will be A into B. So E into B we will get M square L T raised to minus 5 A raised to minus 2. Okay. Now 1 by mu0 into E into B. That means E into B divided by mu0. So E into B by mu0 is equal to M square L T raised to minus 5 A raised to minus 2 divided by mu0 is ML T raised to minus 2 A raised to minus 2 A raised to minus 2 will get cancelled. So what we will get M, okay, then L will get cancelled, then T raised to minus 3. So MT raised to minus 3. Now we have to check which of the physical quantities is giving the same dimensions. So anyway, it is not energy. Energy we know it is force and distance is equal to ML square T raised to minus 2. That is that we can rule out. The next one is the density. Density we know M mass by volume. So ML raised to minus 3. That is also ruled out. Then power density and moment density. So momentum density. Power density is equal to power by area. Power by area. So power is equal to energy by time. Okay, divided by area. So energy is ml square T raised to minus 2 by time into area is L square. Okay, So L square will get cancelled. This is mt raised to minus 3. So it is mt raised to minus 3. So power density, you are getting the same dimensions. Mt raised to minus 3. You are getting mt raised to minus 3. Okay. So power density is similar to this one. Next one. The number of significant figures in the number 6.32000. This actually the number of significant figures is actually total 1, 2, 3, 4, 5, 5. So number because after decimal all the figures are significant and the 6 is also significant. Therefore, there are 5 significant figures are there. The dimensions of magnetic moment are. So, okay, magnetic moment. So we know that magnetic moment. What is magnetic moment? Magnetic moment is actually current into area. That is IL square. Okay, that is IL square. I means for I will AL square. So AL square. Sometimes we write I also. Anyway, no problem. Here we are using A. So we will write AL square. So the dimension is AL square. Next one. If the length of a wire is doubled, radius is halved, then resistance will become how many times it is asking. So we know R is equal to rho L by A is equal to rho L by pi R square. Okay. So length doubled means rho into 2L divided by pi. R is halved, right? Radius is halved. So R by 2 the whole square. So rho into 2L means 2 rho into rho L divided by pi into R by 2 means actually R square divided by 4. So it is 8 rho L by pi R square. That means 8 times. So the resistance will be increased by 8 times. Okay. Next is the dimensions of Boltzmann's constant. We have to find out the Boltzmann's constant dimensions. So the Boltzmann's constant, from kinetic theory of gases, the average kinetic energy is given by 3 by 2 kT. Okay, 3 by 2 kT, where T is the absolute temperature in Kelvin. T is in Kelvin. K is the Boltzmann's constant. Okay. So what is Boltzmann's constant? Kinetic energy divided by 3 by 2 T. Okay. So 3 by 2, there is no dimension for that. Kinetic energy, you know, it is an energy. Therefore, it will be mL square T raised to minus 2 divided by temperature is Kelvin. So it will be mL square T raised to minus 2 K raised to minus 1. Okay. That is the Boltzmann's constant. Next one, 3 measurements are made as 18.425 centimeter, 7.21 centimeter, 5.0 centimeter. The addition of these should be written as. So when we add the minimum, okay, when added, we have to see the decimal. Add a subtract, we have to see the decimal numbers. So, actually, how many decimal points are there? So, the minimum decimal point is only 1. Therefore, we can have only 1 decimal point. So, when we add, we are getting 30.635. So, when it is rounded to 1 decimal point, we will get 30.6 centimeter. On subtracting 0.2 joules from 7.26 joules, what we get is still 7.06. But actually, here only 1 decimal is there for 0.2. Therefore, the significant figure or that rounded figure will have only 1 decimal. Therefore, it should be around 7.06 to be rounded to 7.1 because 6 it is more than 5. Okay, 6 is more than 5. Therefore, the preceding digit is to be added increased by 1. So it should be 7.1 joules. Next one, 99. The significant figures in the measurement 0.0353 meter is. So significant figures is actually only three significant figures are there. So 0 the trailing 0 is non-significant. Okay. So the number of significant figures is 1.118 into 10 raised to minus 3. So there are only 4 significant digits. So the 10 raised to minus 3 is insignificant. The power we will not consider here. So now we have completed 100 questions now. Now in the next part, we will be covering more questions. Thank you.